Hello, hello. Not getting anything from the chat. Just 1 second. Dashboard's being a little jank. S.A. Nuvon saying, I can't really read the text on my phone. Yeah, that's one of the things that is going to be probably not well set up yet, is the text is probably a little bit small. Zakia looks good. Good to hear. TJ, can't read the code either than desktop. All right, let's bump that up a bit. Okay, that's as much as that'll give me, unless I go in the settings, apparently. Oh, nope. Okay, thought the editor was crashing for a sec. How is that for size? In fact, there's more of the whole window. Does that look pretty good? Pretty important. Revival says everything is fine except the mic. What's up with the mic? Good to see you, by the way. What is up with the mic? Except that it's in my face. That I know about, and that's not much I can do about that. Sounds fine, just teasing. Oh, nice. Of course. Sweet. Cool, no problems. Awesome, that is great to hear. So yeah, it's been a while. I guess, like I said last time we left off, I was kind of going to stop streaming for a while. And I really didn't like that. I wanted to come back and do more of this. But it just I wasn't able to do it as regularly as I wanted to, and that really bugged me. And that kind of sucked. So, yeah. Core the Bird, get yourself a Twitch partnership. I talked to someone about that a long time ago, but it never turned into anything. If you guys keep watching, then I'll get popular, and then I can get one. But yeah, so I wanted to start up this stream. I didn't want to dive right back into the Rostendo project because there's some things I actually want to change about that moving forward. I think I set out with a good goal to like try and stream the entire process. Drew 2, thanks for the welcome back. Good to see you again. Anyway, I think that it probably wasn't actually that practical for me to try and stream everything, even though it was cool to stream that getting started. So I think moving forward, I want to turn that into a project where I don't stream everything. So like if I want to work on that throughout the rest of the week, I might just bang on some stuff here and there and just keep like good commit logs just so we can go over what I did. And then every week coming back, I want to do like, yeah, here's what we did last time. So I want to kind of give that a shot and see how well that works. In terms of contributions, I want to open that up eventually so that we can like get more outside contributions. I mean, if I'm not going to stream everything, then there's not too much of a reason not to accept larger outside contributions, which is kind of the hang up at first. So I'm thinking I might want to, yeah, kind of open that up. But I just kind of wanted to bring this up with you guys that watch because I kind of feel like that project is as much your guys' as it is mine. So just kind of wanted to know what you thought about that, and I'll just kind of let that sink in for now. And I'll probably start doing that next week. But this week, so I'm on vacation for this week. It was my birthday a couple days ago and Christmas. That was pretty cool. So now I started a project a couple weeks ago, just another emulation project, because it's been a while since I've been working on one of those. And as you all have probably guessed from the title, where did my picture go? There, it's a Virtual Boy. So Virtual Boy is, I don't know how much of you guys know about this. Move away 00, my birthday, thanks. I don't know how much you guys know about the Virtual Boy, but it's really crappy. Now it's this really cool like VR venture that Nintendo did in the mid-90s. Before its time, same hardware designer, or at least lead on the hardware design as the Game Boy, Gunpei Yokoi. It's actually a really fascinating piece of hardware. It has these two so it's basically red and black, and the way it works is you have these two vertical strips of LEDs and mirrors. You have one of these for each eye. It was like prohibitively expensive to, in a lower cost device like this, actually produce full screens for each eye. So instead there's a vertical strip, and there's an oscillating mirror that will reflect that vertical strip of pixels over your eye. And because of the, I can't remember what it's called, the photo something processes of the eye, but basically means that things stay in your eye for a little bit. Photo persistence, is that the word? Because of those properties of the human retina, it actually makes a screen. And if you've used one of these in real life, I have one on the table over here, but I don't want to get up. It actually looks pretty good. Like it's a bit of an eye strain to get the proper perspective. Like it's not that well put together, and it sits on the stand because the oscillating mirrors, you can't really move your head around. Persistence of vision says move 100. Thank you. It's that. So it has to like sit on a table, and you're like leaning into it, and it hurts your neck and back, and it's really, really crap. But you know, now that we have like Oculus and some of those other things that are coming out now, and like 3D TVs, it's kind of a cool system to play with, because the games are actually really smooth. It's got a little 32-bit RISC CPU, runs at 20 megahertz. It also has a pretty cool audio chip that's, well, not as cool as it probably could have been, but it seems to be pretty decent. Anyway, so it's an emulator I actually wanted to start a few years ago. I gave it a shot in like 2013. I didn't get that far. I had issues at that time understanding, especially like the interrupts and exceptions. And I was trying really hard to make everything like cycle accurate, which I think was kind of a mistake starting out with a system that's as complicated as this, because there's like the CPU has I don't think it has a data cache from what I can tell, but it does have a instruction cache. And that makes timing hard. At the same time, there's a lot of contention on the bus that's a little bit more complicated than like some of those 8-bit systems where it makes a lot of sense to do cycle accuracy. Because that's the other thing, is the CPU runs so fast that that kind of accuracy you don't need it to run most of the commercial games. And it's, I think, a better starting point to not worry about it, even though it would be a lot of work to retrofit that. At least you can kind of debug a lot of the hardware besides the CPU. So if you ever wanted to, you know, re-implement the CPU from a cycle accurate perspective, or with that goal in mind, then you could actually do that, yeah, a little more practically. So anyway, I've been working on that a bit, and let me pull this up. So over here, I've got the repo page. I'll post this in the chat. This is VBRS. That's like the work in progress name of the emulator. Been working on it for a couple weeks, and it's actually starting to work pretty well, and I'll show you guys that in a sec. This is a work in progress name. The status is also a little outdated already because we've gotten a bit farther. We as in me. But what I'm hoping to do, and why I also brought up like my vacation and everything, is I actually want to like spend the rest of the week working on this just for fun. And then that's probably as far as I'll get into this before the new year. Because in the new year, I've got some demo scene stuff I want to work on. Again, I want to start streaming regularly on Thursdays. So yeah, so I'll probably be switching to Rustendo then. But for now, I want to indulge a bit in this emulator because it's actually pretty cool. So what I want to show you is I want to show you this emulator running to show you where we're at. So then here's a big console. Whoop, really big console. There we go. Because there were a couple things here. First, I'll just run, I think Bound High is the game that actually works the best right now. So this emulator right now just spits out a ton of like console log stuff. And I know the font is going to be a bit small in the log, but it's moving really fast anyway, so I doubt it'll be that useful for me to really upscale it too much. Unless I actually go into what it says, which I probably do that. Let me see if I can set this stuff up. Actually, what font size was this? 16 feels a bit bigger than that, but let's go with that. Try that. Nice. Bring this up. Okay. So what you're seeing here is you're seeing a bunch of console output that's basically just like all the stuff I haven't implemented, just print stuff, and there's some extra things like the current frame duration, that kind of stuff. And then you have the actual emulator running over here. So I'm just going to step through this game a little bit. And so we have like this initial Virtual Boy screen. You can already see that I'm doing red and cyan for the right and left, actually, because right ends up being the red one. But we can get through a couple menus. This thing's actually running real time. It's 50 hertz refresh rate. We can see this little logo thing that gets 3D, which is pretty cool. And I can actually get into the game in this one, not in a lot of them. And there's, of course, graphical glitches. What you saw there is the hardware can actually... So basically all the drawing in Virtual Boy is 2D, but it draws to like left and right. Or if I with Twitch video encoding, that may have just been a particle stream. Let me... I'll move the console out of the way for the most part so we can... I bet that's pretty trashy. So this will actually get pretty far into the game. Let me go ahead and just step through a bunch of this. I'm just hitting enter, which I have bound to the system. And I can't let it go into the demo in the game or else it'll crash. But yeah, the graphical glitches you saw there is the Virtual Boy basically does everything in 2 dimensions, except that it has a different left and right screen. Thrasher HT, how's it going? And the problem there is it can do like with certain backgrounds, it can also do like scaling and rotation, very similar to the Fine mode that the Super Nintendo has, which is pretty cool, but I totally haven't implemented that. So like the logo, when it comes in, it has like this glitch on the right side, and what it's supposed to be doing is kind of bouncing in. But of course it didn't, because I haven't implemented that. I just display those as normal backgrounds for now, because that's way, way easier. Excuse me. Skay, how's it going? So I can get into the game, then you can see these menus get progressively more 3D, which is kind of funny. So this game starts with like I don't really know I don't know too much about this game because I haven't played it yet. But it starts with this cool cutscene, and yeah, not much more to say about that. Again, you can see more of those scaling bugs. But generally, this thing runs pretty well. I mean, it runs at the right frame rate. A bit slow, but that's, I think, mostly just because of all the things that's printing. And when this little cutscene's over, I can skip this, but I want to let it play through because it's kind of cool to watch. Skaz, does it play Mario Tennis? Not yet. It gets... I can explain why, because I know why it doesn't get there, and that may be what I work on today. Urkra, damn, I actually managed to catch one of these streams live. Awesome, good to see you. Thrasher HT is the N64 emulator bench remote. Yeah, I'm going to pick that up next week, I think. So now I'm in the game, and another thing is you can see in the background there's some parallax stuff. I can move a little bit like right and left, and you can see that change. And then there's this like floor that it looks like I'm kind of supposed to be bouncing on, but it's not aligned correctly. Again, that is also the scaling that I haven't done yet. You can see there's these aren't actually sprites because I haven't implemented those either. These are on background layers. But the goal of the game is you're supposed to bounce on these. And yeah, it kind of works, but if I go out of bounds, it'll crash. Let's see if I can do that. There it goes. The reason why that crashes is the reason why I can't play Mario Tennis. In fact, I can pull up that ROM. Mario Tennis is one of the really cool games for this, actually. Like, it had a couple games that are actually fairly fun, but none of them really sold the VR thing very well. So this is Mario Tennis running, and it'll be glitchy. Like, this doesn't look right, and then Mario gets ready to serve the shot, and then it crashes. And the reason why it crashes is because I haven't implemented any of the floating point stuff in the CPU. So what you get here, if I can show you the output, is that main panicked on unrecognized opcode bits. And this happens to be the prefix for all the floating point stuff. So I just haven't done that yet. So I expected to explain this a lot throughout the stream as people kind of flood in. I still want to do the N64. I'm going to start doing that next week. And I want to start doing it more regularly, and I also want to start working on it a little bit off the stream. So, MoveAway00 looks like you got it covered, so thanks. That's exactly the clarification. So I want to kind of show you what some of this like wall of text stuff is. Let me pull up a game that actually gets far enough to be interesting. Well, actually, Bound High is a decent example, but I think there are some simpler ones. I'll pull up Wario. because it's pretty cool. It also gets to a point where it kind of works and kind of doesn't. I can kind of show you why in this. So one of the things that I did with like in the way that I implemented this first is I actually started with a debugger. So the thing will now it actually starts running the emulator instead of just dropping into the debugger immediately, because it actually runs well enough to do that. But especially initially, like 2 weeks ago, it would just drop straight into a debugger. So like if I hit F12, which is sort of my toggle key for that now, I can pull this up. And now I think you can see that on the bottom of the screen. I can pull this up. Now this will actually drop into a little console here, just in the command line. And what I can do is I can say like, I will like disassemble a few instructions. It disassembles 4 instructions by default. And the reason why it only does 4 by default is because normally when you start execution, it starts like at a really high address in memory. If you do more than 4, it'll wrap around to the VRAM, which initially I didn't have memory mapping for, so I could probably increase that. But of course I can just like enter a number like 20. What this does, it actually disassembles the code. And this address here in particular is where the code was executing when we broke into the debugger. Which is really, really nice. So like, for example, if I go F. Oh, I don't remember the entry point now. Let me look this up. It was, and I'll pull up the documentation that I'm mostly looking at in a sec. I'll actually paste that in the chat now. The documentation that I'm mostly using for this is really good. Like it's called the Sacred Text Scroll, which is a really funny name for it. I'll paste this in the chat. And it's made by some guys over at a website called Planet VB, Planet Virtual Boy, which is, by the way, an awesome site in terms of like a fan site dedicated to a console, but it has a ton of really great stuff in terms of like hardware preservation that just makes me so happy to see. Like they have old magazine scans. They have like the original debugger software you could get. They have disk images of all this stuff. Pictures, such cool stuff. So first of all, that just makes me super happy. So you guys got to check that out and give them some love. But yeah, the Sacred Text Scroll is one of the documents put up by one of the guys on like their forums or whatever. I'm not that well connected with that scene, so I don't really know who's who. But the guy is called Guy Perfect, I think. Anyway, this is basically just a collection of a bunch of known information about the Virtual Boy. And if you've ever seen any of the No Cache docs, it's just like a really popular, I believe No Cache is the name of the guy that does them, but it's just a bunch of, again, documents like this that even look like this, because this is trying to look like those, where they just collect a ton of information about the system. And one of the cool things about this in particular is that it has this change color thing here. So it's all red and black, which is a little bit kitsch, but I really like it. So this, I'm just looking at the little memory map here. It just has tons of stuff. And like, so I've also been using things like the CPU manual, and those kind of things, and just like cross-referencing going back and forth. And this is basically correct for what's there, other than some of the picture processing stuff is a little bit wrong, but this is like a version 0.3 of this document or something. I expect that to improve over time. And it's little things and stuff that I found in other documents like patents and stuff like that. So anyway, here's the reset vector here. So it's just all Fs and then 0 at the end, which makes sense. Move that out of the way. So, whoops. Oh yeah, it's G. So the debugger just has a bunch of these little commands, like G is go to, and that moves our kind of cursor there. So I can like go to the entry point where this would have started, and I can disassemble some instructions. And you can see here, it's basically loading an address into this R1 register and then jumping there, because there's only like 16 bytes at the top of the address space here. So all it does is just sets an address to jump to. This CPU, by the way, is an NEC V810, which I don't really know of anything else that was used in. It's actually kind of hard to find like debuggers and stuff for it. I think Radar 2 just got support for even Virtual Boy stuff, but I wanted to have my own in here anyway, so I could also do things like look at memory, like you can look at like VRAM and stuff. Anyway, I want to go to where this jumps to just to kind of show you what this is doing. So this basically loads into R1 this value in the high and this value in the low. Of course, this ends up being sign extended, but in this case, it doesn't matter. So if we go to a FFFCE956, it's G again. And this little prompt is not that fancy. I don't have like history and stuff in it because the libraries I looked at didn't cover all the platforms I wanted. So I just, yeah, didn't mess with that. And then here I can like disassemble more instructions. Like this would be more properly the entry point of the code. And then we could do other things that are pretty useful. Like there's actually breakpoints. So we can like add a breakpoint in like Fe40 is the, I think it's our breakpoint. This is the VIP interrupt, which is just like a general interrupt handler for the video hardware when it does anything. And then you check, like, there's these interrupt pending registers that you check, like, oh, what actually caused this? So then I can, like, continue. And I guess that interrupt wasn't set up yet, but if I get through a couple screens, I'm guessing that'll break in there. Oh, yeah, this is Wario. So, by the way, I haven't implemented sprites, and these next couple screens are actually only sprites, so they actually don't show up, but I do get to the title screen after that, which is what this is. So that's pretty cool. Implete, geez, last time you were streaming, I can't even remember it. Yeah, it was a while ago. Skaya says, have you done the Sign a Core challenge? I'm not sure what that is. Googling. It's a programming challenge. You can use any language you want to complete sections when you're during the convention. So just tiny skim. It's just like a general coding challenge. Just a bit curious. What's going on now, by the way? Oh, here, let me hide the wall of text. What's going on now with the game is it's doing the demo. So like Wario should be running through the levels right now, which is pretty cool. But of course, I'm not drawing sprites, so you can't see him. But I'm a bit surprised that that interrupt never fired. Hold on, let me see if I did the right one. Oops, breakpoint. That should be the right address. So maybe this game just doesn't do it. I just wanted to show it because it is actually pretty cool to see. Like it's really useful because they're like for example in bound high. Let me do that again. There was a part where I had like some graphical glitches for like one frame. And one of the things that was really nice here was I could actually set a breakpoint in that interrupt and just step by frames, which is really nice. So let me get to roughly where that was. So it was right after this. Let this fade in, and I'll break like about here. And now we can add a breakpoint for that handler there and continue. And now it broke on that breakpoint, which is really cool. Oscar says, it's by the creator of Advent of Code, but you create a small VM and reverse engineer a binary for it. That actually sounds nice. Is it pretty tough? I bet it is hard, but it sounds actually really cool. I might check that out. It'd be a cool thing to stream, actually. But anyway, so now every time I do continue, it'll go forward a frame. And like I said, this interrupt can actually trigger by more things, or like a bunch of different things that happen throughout the frame, like when the hardware starts drawing, when it stops drawing, when it starts sending data to the displays. A lot of details I know I'm kind of skimming over. With this system's kind of weird, but I just kind of want to share what I'm working on. Anyway, I know that it's actually doing everything per frame because I get a bunch of this debug information that the renderer stuff is using. And it's so like the Virtual Boy has a bunch of different windows, they're called, or worlds. And they're basically just a bunch of layers. And it will draw, like they're at a certain, like these tables in memory. It starts at the 31st one, just goes down to the 0th one. Unless it hits one with this stop bit that says true. Anyway, when I actually implement the drawing, I go through these tables and just kind of parse out all this information. I print it all out for debugging, which is really, really useful. But yeah, in this case, I can actually step by frames. If I want to, I can step single instructions, which is fairly exciting. I can also, again, still disassemble, and if there's a breakpoint on a line, I get this little star here, which is really cool. And yeah, that actually probably, judging by the address here, it wrapped around into memory and then couldn't disassemble this because it wasn't actually an opcode. Anyway, you can see that this is actually pretty useful thing to do. The nice thing is that starting with this, especially with this kind of RISC CPU, is you could just like step through instructions. Let me just kind of break into some of these. Move this again. It was a really good way, like, it's really cool to start with that kind of workflow, just because like you could debug a lot of the CPU just kind of in isolation really easily. And then again, like if I wanted to know if interrupts were triggering, I could go as like set breakpoints in those and those kind of things. So it's still pretty useful tool. And the other thing that didn't do in the N64 project, but I actually want to like start on pretty early, moving back to the N64 project, is building out that debugger a little more as a good way to continue working on that. So I guess I could just talk a little bit more about this code because it's pretty cool. The general structure is okay. It's not great. Basically been working on this, like I said, for a couple weeks. And there's some parts that I'm really happy with, some parts that I'm not necessarily happy with, but you know, that's how it goes. Thing is starting to work. So if we go into main, that's, you know, nice place to start. Basically just gets the ROM file name from the command line here. Just prints a little bit of metadata about it just from the header and stuff. This is all done with this ROM module here, which basically is just a bunch of bytes with some functions to read some of the metadata. And I have these as functions instead of just parsing them out initially, because if you want to like change the data in the ROM, which I actually don't think you have an interface to do, but I always thought that maybe that would make sense and it could just parse them on the fly. Everything here is just super straightforward, except the character encoding is a weird thing called Shift.js, which I hadn't heard of before. So this is for like the ROM title in the header of the ROM. As it turns out, I think it's just called encoding. Yeah, the encoding crate for Rust actually supported Windows 31J, which is a superset of that. So just a comment about that. But this is really like straightforward stuff. It's just reading off certain offsets inside the header and giving you the information. So once that's done, then we actually create the emulator and have it run. And this is where the code gets not that nice. It's a bit convoluted just because it has like the debugger and the normal execution kind of like tied together. I kind of want to hand wave that away for a sec and dive into the Virtual Boy struct, which is kind of like the heart of what's happening here. The Virtual Boy has an interconnect and a CPU. The interconnect is, you know, like it owns like the image processor and the sound unit as well. There is the startings of a sound unit, but it's like not at all implemented. So I haven't really talked about that. And it has a step function, which is kind of the heart of the emulator running here. And the idea here is that when you tell us a step, it's just going to step the CPU by one instruction. And that's okay enough for now. And it'll also give you how many cycles it actually stepped. And that's basically the whole interface, which is, yeah, decent. The CPU itself is actually fairly straightforward. It's got a bunch of these general purpose registers, has 31 of those, and like the data sheets it'll tell you 32, but the first one is 0, which I believe was the same on MIPS in the N64. Also the initial program counter, a bunch of registers, so it has like a program status word that I have split up into a bunch of booleans and stuff here, other than this mask level, which I actually don't implement. And then it has a bunch of stuff for exceptions. And you can see I initialized most of the registers to dead B for beef. And this is because they're like undefined on startup, and this just makes it really easy for me to, as I'm debugging, see which ones have been used and which ones haven't. So that's really nice. One of the things I wanted to implement in the debugger is watch points. So like breakpoints, when you have code execution that goes to a certain place, you can break there. Watch is more like, let's watch this one register or this one, you know, address. And then anytime the CPU tries to access that address, like with a read or a write, we can break there. But that was a little more involved, so I haven't ended up doing that. It tended not to be terribly useful because I could always just like put printing and stuff in those registers, and that was pretty good. It's generally pretty straightforward, the stub function, because we like take the PC here, read a half word from the interconnect, and then we have this next PC thing that we modify. We get the opcode, where this is where I just parse an opcode from a half word. And so half word is a term. So like this is a 32-bit system, so a word is 32 bits, half word is 16 bits, and then a byte is 8 bits, and that's common terminology for this kind of thing. At least in all the documentation for Virtual Boy, it's all referred to as those terms, so that's why I use those here. The instructions have different kinds of formats that we check, and that has to do with like how they're decoded. But the most important part here is that some instructions are 16 bits long, some are 32, so we might have to read a second half word depending on the instruction format. So we get the instruction format and say if it has a second half word, then we're going to read the second one as well. Ignore that. And then we just branch on opcode. And the implementations of a lot of these are really straightforward. Like here, we're going to add 2 registers. So we take the left-hand side, right-hand side, and then do an add. This add function like affects flags and stuff. And I go through these like format 1, format 2, format whatever functions here. And the idea behind those is that like they will all have the same kind of decoding from the 2, like the first or the second half words of the instructions. And they'll give you like an immediate value and a register index or something like that. That's the same for all these. And I believe I made that generic. So this all just gets folded in the code, so it ends up being silly fast. But it's pretty straightforward what I think basically all the instructions do. There's some branch ones that are kind of weird. And there's like some multiply and divide stuff where like the flags get a bit annoying, but that's basically all it is. And then there's exceptions, which is also used for the interrupt mechanism. And this is not fully implemented, but basically all it's going to do is it'll either reject the exceptions. This would actually say request interrupt. And then if it's accepted, it'll treat it like an exception, which is a little more correct. But anyway, if it's basically already in a non-maskable interrupt or it's in a different exception or the interrupts are disabled, it's just going to reject that. Otherwise, we print that we're entering this. And then we, basically transfer execution to that, fill in some registers with stuff. Return from execution is basically doing the same, the opposite. Pretty straightforward. And then you have the functions that actually do the decoding. So generally, like this is a really straightforward CPU, and I think that has a lot to do with just the fact that it's not MIPS. And the only thing that I haven't really... So I guess there's a couple of things I haven't implemented because I haven't touched it has some floating point instructions I haven't touched. It has these things called bit strings that I haven't touched. And it's like you have a word like a bit string is literally a string of bits. You have a word that starts in, you have an offset within that word that the bits start in, and then you have a length of bits, which is how long it goes. And there's some instructions for like moving those and searching in those, which is a bit dumb to have in a processor, but this one has it. And I haven't implemented those, and both those and the floating point instructions can actually raise exceptions internally, and that's why I haven't done exceptions other than the interrupts. And so there's a little bit of things there, like the system can actually handle what's called the duplex interrupt, and so if you are in an interrupt handler and an exception occurs, it can handle that gracefully in a way that you can recover from that properly. But if you do something like an exception within an exception, then you're screwed, and then it goes into that's a fatal error. It basically goes into this wait state until it's reset. And I also haven't implemented that. Skas, what is the point of the interconnect? So that's basically all the CPU anyway. So it's a good time to break that. So the interconnect is basically just like an object that contains all the other parts of the system. So that we can have like a reference to all those different things as sort of one unit that we can pass to the CPU. So when you tell the Virtual Boy to step, it takes in a video driver because it's like basically how it buffers the output as well. And it sends into the CPU, it sends the interconnect and then the video driver. And the reason why it sends the video driver is because the interconnect needs it when you actually step those. So actually, if we go back to this CPU, you can kind of see a little more how this fits together. So the CPU in this case is kind of running the show. And basically, after every instruction, we figure out the number of cycles that would have taken. And this is just wrong. I'm basically just like taking the number of cycles based on the opcode and then whether or not a branch was taken. Because like there might be reads and writes that happen on certain cycles within the instructions, and I'm just ignoring all those. A couple of these are a little bit incorrect because they also like the system bus, and this system is a little more complex than a lot of the older 8-bit stuff. So like there might be different weights, different things, like the cartridge ROM has a different timing, different timing requirements than like the DRAM or the work RAM and stuff like that. So also with DRAM, which is the work RAM, there might be like refresh cycles. So there's like a lot of things that can make instructions take different number of cycles, and also the instruction cast I'm not implementing. But this is kind of a good enough approximation, I think, just to, progress the rest of the system enough. Anyway, so get the number of cycles that opcode would have taken. Again, definitely approximation. And then we tell the interconnect that this many cycles happen, and the interconnect will then like update all the other different hardware, and it may also produce an exception code. And an exception code, in this case, is really just an interrupt, so I might name that differently. But the reason why those are kind of confusing in this case is because the CPU treats them the same, other than how they're triggered. So I just kind of call everything exceptions. Anyway, if we go to the interconnect, we can see the interconnect has the ROM, work RAM, save RAM, the video hardware, the audio hardware, hardware timer, and the gamepad. And when this steps, if we go down to the bottom here, so when the CPU tells this to run, a certain number of cycles, excuse me, we get, the timer will run, and then the video hardware will run, and if those, basically return true, which is whether or not they're going to generate an interrupt within those cycles, then we return that here. And these different interrupt codes, the reason why they're here and not in those respective units is because it's how the system is wired that determines these, not the actual hardware themselves. Or like the timer doesn't know about this. The timer just knows, oh, I have an interrupt. So it's going to raise it with this code when it goes out of the interrupt, if that makes sense. So the interconnect is just kind of the rest of the bits that are all connected together outside of the CPU. And the reason why it's separate from the CPU is because we need mutable reference to the interconnect within the CPU. And if this were all owned by the same object, that wouldn't work. Alternatively, we could also have the CPU take in all of these different elements individually, but that's a little less ergonomic than just stuffing them in something called interconnect. So the other thing interconnect does rather naturally is handles memory mapping, which, if you guys remember from the Rostendo thing, this is basically the same, where it has like read byte, read half word, all that stuff. And it actually uses a little bit of a different piece of code to do like address decoding, but then this will actually go and affect stuff. So like if we have an address that was mapped to the video unit, then we're going to go tell the video, read a byte from the video unit, stuff like that. So generally pretty straightforward on this level, and then all the more complicated stuff happens a little bit below this. This guess is, so could you call it a motherboard? I want to say roughly, because like, what do I want to say? I don't, you can kind of think of it that way, but like the CPU would also be part of the motherboard, or like it would be on the motherboard. It like the interconnect is more of like an artificial construct that we make in a lot of Rust emulators because of just how we put stuff together. So I don't know if it's the best analogy, but you could kind of think of it that way. It is basically everything that's not the CPU is in the interconnect. So I'll give you roughly, but I'm hesitant to say that that's definitely what it is. Also, 50 viewers. Thank you, guys. Yeah, so that's basically all this is doing. The more, like, there's some more basic units as well. The SRAM is just like the save RAM in the cart, and that's basically just reading and writing from this vector here. Or actually, this box slice is what it actually is. It's 65K of that. That's actually wrong. Now that I see this, and I know why that's wrong. Because I forked it from the work RAM, which, as you can see, is basically identical. And I forgot to change the size of this to be basically 16 megs, not 64K. So that's wrong. Skis says, why isn't the CPU in the interconnect purely to please the borrow checker? Yeah, pretty much. In fact, like the emulator stuff I've done in C++, I basically do model it that way, where I have like the system kind of owns everything, and then you tell the system to read and write bytes, and it's more analogous of then it's more analogous to something like a motherboard, because you treat it like it has a bus, and you treat it like like you can actually get at the other hardware units. So it is basically a way to get around the borrow checker. Anyway, I'll fix that later when I actually start implementing this properly, because this also doesn't persist the save RAM right now. It's just something that the memory mapping can actually read and write to for now, so that I can get further into some games. There's a lot of like an emulator really covers a lot of different things, because you have like the emulation itself, which is what I've been mostly focusing on. And then you have a lot of other sort of higher level things like the debugger in this case, but also like menus and things like persisting save RAM that I'm just not as interested in yet. That of course are very important if you want to make a usable emulator, but if you're just learning and it's a little hobby project, then don't have to worry about that as much. At least I like to defer those kind of details. This guy says, did you know that Rust's mascot is Ferris the crab? I did know that. I found that out a while ago, but it was I was really surprised to hear that. I thought that was pretty funny. Hamus, oh snap, Ferris is back. Good to see you, man. So that's the SRAM and the WRAM. What else does the interconnect have? Has the video and audio units, the VIP and the VSU. The VSU, the audio unit, is very simple. It's just like dumping stuff. This stuff is not implemented. That's actually really good for now, because like if I'm not going to implement it, I still like to know that stuff is writing to it. Like here, you can see a bunch of stuff was written there. It's really cool. Like there's an intro to Bound High where, like we saw earlier, where there's this little cat head that like comes out in 3D, and the cat meows. And the cool part is you can actually see when all this text is scrolling by that when that's supposed to be happening, you see a bunch of these writes go to those registers. And the nicest thing that this has been is, especially when I was getting the CPU up and running, we got a lot of like just a lot of debug output for what the CPU was touching, and you could see that it was touching sensible addresses, which was just a huge like sanity check. Generally, I've had very few problems getting this CPU up and running, and I think it just has mostly to do with the simplicity of this particular system. But that's been really good. Dom170, how's it going? So that is that. There's the little timer, which also was pretty simple. It's basically just a countdown thing. I think the only trouble I had with that was some details about how it raises its interrupt and how it basically stays raised until you acknowledge it somehow. And the way that you do that is very specific to this timer. The sacred text scroll over here actually had a little bit of wrong information about that, but I found the correct semantics I found it by guessing, because there was a game that was very, like I was disassembling the code and it was very clear how that was, like what it expected of the timer. And the fact that mine was wrong meant it just didn't work. And so I kind of guessed at what the proper behavior could be, kind of sensibly. I can talk a little bit more about the specifics actually. The specifics was that when the interrupt, or when the timer is like fires, like it's done timing, or like an interval has passed, it like counts down from an interval. When that passes, then it raises an interrupt, and that interrupt will stay raised until you basically until you turn the interrupt enable off, and then that will disable basically act the interrupt. But then you're also supposed to set this zero status thing to, like, when the timer counts down, you get zero status becomes high, and also interrupt enable, or if interrupt enable becomes high, you also get an interrupt, which is this interrupt thing here. Anyway, the issue is that the sacred text scroll thing had it wrong and said that you basically have to turn the interrupts off and then set the zero status to false. And I know why it says that, because I found another piece of documentation that also says that, one that is supposed to be quite correct. But it's actually not true. You actually don't have to set the zero status back, and the timer will still fire. So all you actually have to do is disable the interrupt enable, and that's enough to acknowledge the timer. And that's what this particular code was doing. And then, yeah. So of course, to fix that, I make this zero interrupt state instead of just having it based on whether or not the zero status is true and the interrupts are enabled. And then I just set that when the thing fires. And then if you turn off the interrupt enable, then yeah. clear that line. So other than that, like that was really straightforward. Then the gamepad, of course, is fairly obvious as well. I mean, it's just a bunch of like a button struct. The gamepad just has bool states for whether or not all these different buttons are pressed, and then it has a control reg that I haven't implemented because there's like it's a little serial protocol that the system talks to the controller with. And you're supposed to actually like fire off either hardware reads from that serial port, or you're supposed to do them yourself in software. And these control registers allow you to do that. What I do is I have all these states set based on the buttons, which is incorrect, because like you should be able to use the buttons or whatever and then trigger a hardware read, and that's when it basically, will talk to the controller and latch all those states. And it can also raise interrupts when it does that, but it doesn't seem like any of the games really rely on that. And for simplicity, this was just easier to implement. So that's as far as I got there. And then the rest is the video hardware, and I'll take a break before I dive into that, because it's a lot of code. Generally, it's not that complicated, but it ended up being a lot of code. Urkra asks if I could talk about how the debugger works. I totally can. Don170 said, I saw most of the recorded streams on your YouTube channel. I wanted to figure out how computers work by making a basic emulator. That's a great way to do it. That's why I'm doing it. That's pretty cool. Yeah, so the debugger, I'll go over some of the top level code. But basically, if we go back to the Virtual Boy, it has this step function. And so the whole execution is just based on telling the CPU to step an instruction and then getting how many cycles it took back. So like when you're running outside the debugger, it's basically just a main loop that I could show you in Emulator. So this emulator.rs file, if you're following along at home, contains like the normal main loop, but also the debugger main loop. And the normal main loop, the reason I bring that up before the debugger one is because it's kind of easier to see. So when you tell the emulator to run, basically while the window's open and you haven't hit escape, I get the start of the current time when the frame starts, and I do this to cap the execution time so that we actually get like 50 hertz. I have this different mode here. So like when we're running, we just run a frame. And then if we produced a video frame, we'll pump that to the window, and then we see how long the frame took. And if it was less than 20 milliseconds, then we're going to sleep the rest of the time. Also print out the frame duration, which is pretty useful. So that's like the main loop. And if it's running, it'll run a frame. If it's debugging, it will run debugger commands. And I'll get to that in a second. So when we just run frame, we have a state with whether or not we're going to start the debugger. And the code here is not that clean, but it works. If F12 is pressed, we're going to start the debugger after this. We also read the input keys, which basically passes everything to the gamepad from the keyboard. And all this is doing here is we have this frame cycles variable here. And while that's less than the amount of CPU cycles per video frame, then we're going to add it here by stepping. So we just like increase it by the amount of cycles that the actual Virtual Boy ran when we told it to step an instruction. At every step, we also check if any of the breakpoints have been hit. So breakpoints is basically just a hash set of U32s, which is how big our address bus is. If that contains any of those, and you'll notice I don't do any like address decoding when I actually have the breakpoints, which is probably incorrect, but works more than well enough for this. So anyway, if the CPU is at a breakpoint, then we're going to start the debugger as well, and we're going to stop execution there. And you can see I have a couple different places where I check if the frame cycles is greater than the CPU cycles per frame. And there's kind of a reason why I do that. That's basically, and also why this kind of persists across frames. And the reason is because, like, if I tell the CPU to run 400,000 cycles, which is, I believe, how many cycles per frame it was, it might actually run like 400,002. And what I'm trying to do here is then on the next frame, I'm going to ask it to run 400,000 minus 2 cycles, and that's kind of what this loop is doing. And so we just want to make sure this frame cycles variable is correct, so we can run the correct amount of cycles. Otherwise, we'll get some like timing drift, and that's not so much of a problem right now when there's no audio, but when there is audio, that kind of timing is going to be very important. Anyway, if we determine that we want to start the debugger, we're going to start the debugger, and the debugger loop actually looks a bit simpler, but all it's doing is it's still running like a 50 hertz loop, just so that we don't use 100% CPU in our main loop. And basically what it's doing, So this starts the debugger. We go into debugging mode and we get our cursor, which is where the current Virtual Boy CPU is. And we also disassemble an instruction and print the cursor just to show you what happens. Or like I can show you there when it breaks. So I'm running a game and I'll hit F12. And here we have this right here. So this stopped and added the cursor, and then it disassembled this instruction, printed that out, and then we get our cursor here. So this just kind of shows us, yeah, where we were. If I do disassembly here, you can see that's the same instruction. And this is probably this is actually definitely an infinite loop that's just waiting for interrupts. But anyway, when we're in the debugger mode, we run our debugger commands, and that's basically just popping a bunch of commands off of out of a queue, or it's actually just a bunch of strings out of a queue. And there's a separate thread that is sitting there listening on scdin. So that way, like our window and everything will still get updated all the time because that's always running in that 50 hertz loop. And then we're able to use the command line without blocking that. So yeah, there's just a listener for scdin on another thread that just takes, every time it gets a line, it just puts it on this queue. So then when we run the debugger commands, we go through all these different, if there are any messages on that queue, we take out those strings and we try to parse those as commands. And then we just do whatever the command said. So this is actually pretty straightforward on that level, at least. There's the command module that just has the different commands here as a struct, and then we have this from str, so we can actually parse them, which works pretty well. And this code is actually basically verbatim the same stuff that we were doing in Rustendo, because because it works. But the different commands will do things like show registers, and here we just print out a bunch of stuff. And the thing is that when like the commands themselves are really straightforward, and they usually will just do a couple things. Like step will just run one virtual boy frame, and then we also have this CPU cycles thing here. So I really should abstract somehow, but I'm not really sure how I want to do that, which is kind of why I just left it all in here first. Wanted to get it working first and then clean it up after. But really the main point again, and this is why I started here, is it's all this main like 50 hertz loop, and it'll either just run the different debugging commands, which might like step the emulation further, or might just show you some stuff. Like when we're in debugging mode, it's basically, the emulator is basically frozen, but the main loop is still running so that we still get proper window updates and everything. Otherwise, if it's running, it will run for a frame. And another reason I brought up that like frame cycles thing is when we step in the debugger, like if we step through a bunch of instructions, we also want to account for that when we go back and start running stuff again. So that's why the step command also keeps track of that stuff for us. So the next run frame that it calls will like run a lot less cycles because of all the cycles we stepped here. And if this steps more than a frame, then it will know to do that less. So that's kind of a long-winded answer, but I hope that kind of helps to see how that is on a higher level. As far as the individual commands, they're very basic. Like show regs will just print out a bunch of registers. Step will step the emulation one instruction. Continue will just swap modes back to the running mode. So then on the next frame, it'll just start running frames again. Another thing that the debugger has, so the debugger has a concept of a cursor. So the first thing that happens when we break into, I also show the code again. When we break into the debugger, which is start debugger here, we set the cursor to the Virtual Boy's PC register, and then we'll disassemble that instruction and print that cursor. And so this cursor is kind of like it's a cursor. It's like where we are in memory. And so this is an address, which is where execution was. And it's literally just a pointer into the memory. And that's usually manipulated by these different commands. So for example, if I show the registers, it's actually not manipulated, but you can just kind of see what that looks like. You can see that some of these are dead beef, so those haven't actually been touched by the code, as I mentioned earlier. But like step, for example, will step the emulation like one instruction. And so that's what happened here. And then we got, so it stepped that once, made sure we keep our frame cycle stuff in check. Then it updated the cursor again to the new PC after it stepped that instruction, and disassembled it so that we could see it here. And after every command, we also print the cursor again. So that's why that showed up. So in that case, like if we're just stepping instructions, if I hit enter, it'll also run the last command. So if I think this is just in a loop waiting for interrupts in this case. But yeah, the stepping will just step and then update that cursor. But there are other things we can do too. So like if I do mem and then 0, M for memory. These are all just shorthands. I have like longer versions as well, but I just kind of threw these together. This will actually show us like a hex dump of the memory. And if I just do M with no argument, it'll take wherever the current cursor is. And this is why it's important to have like a specific cursor. If I just start hitting M, it will just say, oh, what are these, the next 250 bytes, 256 bytes from the cursor. It will display those, and then we'll update the cursor with the new value. So if I sit here and hold enter, it's just going to increase the cursor every time. And now you can see that we actually get to some memory here. And this is in video memory. I just happen to know where that is in the memory map. Yeah, and we actually see those bytes. Cafe Climber, finally catch the live stream. Now if my parents' internet wouldn't crap out every 5 minutes. Another feeling, man. So that's basically what this is. And of course, this memory looks really structured because it's VRAM. That's we're looking at the video memory for this, I'm guessing. So it's very basic commands like that too, though, because like again, continue will just go back into the running mode. Go to will actually set that cursor to a specific address. So for example, if we want to like look at the code for one of these interrupt handlers, we could do like the timer interrupt. We can go to FFFFE10, which is where the timer interrupt is. Again, I just learned these from playing with this debugger, learning about the system in the last couple of weeks. There I can disassemble and say like, oh, okay, so it's going to load this R30 register with, you know, some hard-coded value and then jump there, right? So putting these together, it's going to be, so we can go to that address, right? It's like FFF802BA. And now I can like disassemble some more instructions, and then this is the rest of that interrupt handler. And you can kind of tell that it is too, because the first thing it does is SEI, which, as Hamas just pointed out, he's doing an S emulator. He's going to recognize that. That's going to set the interrupt disable flag. One of the instructions that's typically not on this CPU, but Nintendo added it for this system. So you can look for clues like that, and I'm really happy that I did it this way, because when you have a disassembler like this, you get a lot of sanity checks. Like I'm using the same instruction decoding in the disassembler and in the CPU. So like if I can look at the assembler and read it and say like, oh yeah, so this will load some stuff and then jump there, cool. This will disable interrupts. Like, okay, that actually makes sense. That's like additional verification as I'm sitting there working with this, that like the instruction coding was correct. So stuff like that's just been really nice. And then again, like being able to poke at memory. In particular, when I was setting up the drawing stuff, being able to poke around in VRAM just to see where stuff wasn't all like zeros or Fs was really useful. So I thought that was really cool. This is the first emulator that I did where I did that first. And I did that actually because I was doing some Commodore 64 demo effect reverse engineering recently. And I was doing that in a monitor and one of the other emulators, basically the same thing as this debugger. I just got really used to that workflow of just like having a simple console like this, just poking around that way. I guess if you're used to like GDB or something, that's something you're more used to, but it was never something that I had been very familiar with until recently, and I really like that workflow, so that was really useful. Here's like the code for the show mem thing. It literally just, if there are any like labels of the cursor, it'll print those. Yeah, I forgot about that. That's another thing that I have, is I have labels, so I can do like, I think AL at FFFFE10. And I don't remember the format if I had this before or after, but something like timer, or maybe it's this. I don't remember the format for this. If only I had the code. Label name and hex 232. Oh yeah, it's a dot timer. There we go. So now if we go to that place and I like disassemble, you can see that the labels show up there as well. I mean, it's really basic to build that kind of disassembler once you just have all these little pieces of information, and this just gives you a nice way to do that. Again, I can also like add a breakpoint to the same place. And if I disassemble there, you see we have the label here and also the breakpoint, which is pretty nice. And those the labels and the breakpoints, they're literally just like a hash map and a hash set. Like the labels is a hash map from string to address. The cursor is just a U32. Breakpoints is a hash set of U32. So just super basic stuff. And it's totally fast enough as I'm sitting here, running frames and stepping in the emulator to check this every time, just if our address is in this breakpoints hash map. Hashing int is pretty fast. And then hash map lookups on ints are pretty fast. Hash set hash set lookups in that case. And then there's stuff like add label, just print all the labels. Same with breakpoints, you can add and remove them. There's exit commands, and then some other stuff for the decoding. Matt RVA, hey Ferris, I was inspired to make a GB emulator after watching your stream. I'm nearly finished with it. It's been really rewarding to learn about this kind of thing. Wanted to thank you for that. Hey, that's awesome. Thank you for sharing. If you want to post a link to the emulator, I'd love to see that. I mean, if it's public, that is. I think that's awesome. Like the reason I really like this emulator stuff is you learn a lot about the hardware, and like my background is demo scene stuff and trying to push hardware to limits, like to display something really cool graphically or audially, and just learning about how this stuff works is just fascinating to me. So that's awesome that you guys are also doing that stuff. That's funny. This breakpoint's actually being hit, so I'm continuing the code here. You can see a bunch of stuff is happening between these different times this timer's being hit. Like you can see it's writing to a bunch of the audio registers, which is probably in the timer handler actually, that's doing that. And that would make sense if it's like playing some audio thing, like a sound effect or music, while it's displaying this. Excuse me. So this by the way is a warning message. All the Virtual Boy games open with like this warning message, basically say this stuff is bad for your eyes. Don't do this. It's the only one I think of the entire small ROM collection I have where this is actually only in Japanese. It's usually both. Japanese and English, that is. Yeah. So the only other real part of this emulator that I haven't shown now, which is kind of cool, is the video hardware. So one of the things that I did here is the video hardware. So the interconnect has this thing, like if you ask it to read a byte, it'll map the address and then match on that mapped address. So the memory mapping is like separated from actually reading and writing different bytes and stuff. And the reason why I like that pattern is because like if you read a byte or if you read a half word, the address decoding is going to be the same. It's just you're reading and writing different like sizes of data. So yeah. It's nice to have that separated. Matt RVA says, maybe the warning messages is why the console didn't do too well. Imagine if Coke had warning labels on the bottle saying how terrible it was for you. Actually, I've read a lot of things that say that was the case because like it in particular, it had warning labels saying like this can like basically hurt your eyes if you're under the age of 7. So like parents didn't want to buy this for their kids. Studio C says warnings did not work so well with tobacco, but I guess it's a little different if you're already addicted. Yeah. Yeah, the VIP. So the VIP, because it has so many registers, I did the same pattern there. So like it has its own memory map, which has a few registers. And then, yeah, its own module. And it's a bit complicated to describe all the different things that are happening in this VIP, so I'll kind of brush over a lot of it. But basically it has, like the VIP is the, like, I guess virtual image processor is probably what it stands for, but that's just the name of the chip. In fact, I forgot to bring up board shots. Always got to look at board shots. I think this is iFixit put this up. I'll link this as well. They have a great teardown of this with just awesome pictures. Oh, I love board shots. Here, look at that. Oh, that's nice. So I guess this is it says VRM, so it's probably VRAM. The VPU and the VUE. I actually don't know what's on these different chips. I don't know if I read that and forgot or just don't remember which is which. But as far as I know, like this isn't integrated. Actually, no. Okay, so I actually do know a little bit what's on here. So the VPU in this case has the sound unit and the audio unit, and I'm guessing because I'm guessing there's more stuff underneath here. Look at the back as well. As I was thinking, like, oh, then where would the main memory be? And it's probably these Toshiba chips here. Okay, actually, the VSU here. So this is actually the sound unit in particular. So here's the sound. Here's the memory. I wonder if one of these is a system memory and the other one is memory for the sound chip. Because I know it has a dedicated memory. Anyway, the details there aren't terribly important, especially for not for understanding this emulator, but I just think this stuff's really cool. So this is probably the video chip and also some glue logic. And I believe it also has the display logic integrated on here. I don't know how much of that is on the like mirror displays and how much is on the board. Anyway, the video unit has kind of a few main parts. Like it has a display circuit that's basically dealing with, okay, we have some pixels and some frame buffers. Let's actually show them on these LED displays. And that's like the display hardware. And then it has the drawing hardware, which will, based on some tables in certain parts of memory, basically draw character graphics into those frame buffers. So it's almost like it has, I mean, it's pretty GPU-like at this point. Like it's not just reading out of memory and driving straight to a display like some earlier systems might do. This actually draws into a frame buffer with kind of a 2D GPU kind of thing. And then for the rest of the frame, you could also manipulate those frame buffers yourself from the CPU if you wanted to. And there were a lot of games that did that. And then there's the display hardware that's going in parallel. And the system's also double buffered. So like it'll be, for every frame, it's drawing into one set of frame buffers while it's displaying the other set. So that's pretty cool. So they're basically like, those two different hardware units are, of course, very like reliant on each other, but they are actually like separate pieces of hardware, and it's best to think of them as separate processes, especially in terms of scheduling, like when different interrupts happen and like when the different thing, like when the thing starts drawing has nothing to do with when the things start displaying, because like they're displaying from different buffers. There's a little bit of logic that makes those happen that kind of makes them related, but it's not like one triggers the other. They would work independently of each other. If you remove like the drawing state, you would still have the display, vice versa. But it's relatively straightforward. There's a VRAM, there's like a display state and a drawing state. There's a bunch of like interrupt pending and interrupt enable lines. Whether or not display is enabled, whether or not the display is getting sync signals from the display hardware, which is important. Whether or not drawing is enabled. I don't want to explain that. Some registers for LED brightness and different like palettes in the background. The system's really, it's really weird to me because like other than the fact that like it draws into frame buffers and then displays those, like the stuff it actually draws is these 2D like character maps like you would have found in like the Game Boy or the Super Nintendo. And I guess that makes sense because like again, it was the same hardware designer as the Game Boy, but like it's really kind of outdated, that way of doing things. Like it's weird that it wasn't like a 3D accelerator in this thing, especially when you're pulling double duty with two actual frame buffers. But I guess it would have taken way less time to develop this way because it would have been kind of tried and tested technology, whereas these 3D accelerators were still pretty experimental, at least in the cost constrained market around that time. But so it has that kind of really primitive hardware where like you have these palettes and like everything is like 4 colors. Drawing into those frame buffers. And then it also is kind of funny because the scanners actually scan sideways. So most like basically anything with scan lines is going to scan like top to bottom, left to right. But this is actually the other way because it's vertical strips of LEDs that scan your eye. So like the VRAM is laid out that way to make it more convenient for the display hardware, I'm assuming. So that's kind of funny. Generally, most of the registers is just pretty straightforward setting those stuff. There's a couple more complicated ones like the display control and the drawing control, just because there's a little bit more things that they have to do. I guess they're not that complicated, but there's some states there that are a bit messy. And looking at the commit messages, I could tell you why they are the way they are, but I don't remember all the details here off the top of my head. So there's this big like I/O portion of the code. It's basically just setting registers. A couple of things that are wrong about this, like all the registers for the video unit should actually only be accessible as double words, but I've seen also, as half words. But I've also seen some games have byte access to those, which is a bit odd. I haven't seen any word access to any of the actual registers, although they're laid out in memory often that you technically could do that, I guess. But I guess the system has a 16-bit bus, so it would have just been the same as two 16-bit reads. But anyway, you actually have to support that in this case because there are a lot of games that access VRAM as double words, which I guess would be less bus overhead. Anyway, the interesting stuff happens when like I showed you earlier with the interconnect. The interconnect has this like cycle callback, which will tell all the other hardware to run a certain number of CPU cycles. It's a bit crap that I actually use cycles here because I should actually use like some timer value like nanoseconds, which I use actually for all these different like clock periods, just because that made it easy to think about. Like I could actually do the math in round integer numbers, which is pretty important for timing. Stuff like, are we going to start a new frame based on that basically 20 megahertz, the 50 hertz signal, which is actually supposed to be a clock input from the display hardware, but I'm not differentiating that much based on I'm not really implementing the physical components of the display hardware in this case. If that happens, we have a frame clock that might trigger what's called a game clock. So like, because the hardware is double buffered, because the hardware is double buffered and you may be writing into those buffers, sometimes when you're writing into those, it may take longer than a frame, like longer than 50 hertz or longer than one 50 hertz period, if that makes sense. And the issue with that is if the system is swapping buffers, like which it's drawing to and which it's displaying before you're ready, that would actually be really bad. So because the hardware is actually swapping the buffers, or like swapping at least what buffers it's reading from, you need it to be able to tell it not to do that somehow. And the way they do it is you have what's called a game clock. And so a frame clock will happen every 50 hertz. And then you have a game clock, which is basically a value to divide the frame clock by. So like you could have a game clock every other frame clock or a game clock every 5 frame clocks. And this just allows you to have like a deterministic amount of time that's not just one frame that you can do stuff with before the system will actually swap frame buffers. That's pretty important. So that's what I'm doing here. I'm checking if there's a frame clock, and then later in the frame clock I check if there needs to be a game clock, stuff like that. And I basically just like this cycles loop just goes for however many cycles that happen. This is kind of slow to do it this way, but it keeps the logic really simple. And I basically just update these counters, and if they've gone past a certain period, then something happens. Like in this case, the frame clock would happen. If we're in a drawing state, there's a certain counter that counts down, and after a certain while, that will end the drawing process. I mean, really kind of straightforward stuff. It's just in terms of how like the code looks, it's just there's a lot of details about the different timing of these different components that's just mostly been a lot of digging and some experimentation. And generally, I'm at the point now with this emulator where at least the stuff that's implemented here appears to be quite correct. The stuff that's left is mostly stuff I haven't implemented, as far as I know. There might be subtle bugs here that I just don't know about. And I'm also approximating some things a bit. Like the drawing hardware, it obviously takes time to draw stuff, and it's a non-deterministic amount of time based on what you've told the hardware to draw. So another like feature of this hardware is it may even take the drawing hardware longer than a frame to actually draw everything you tell it to draw. So it has some hardware mechanisms for that as well, which is called drawing exceeds frame period. And if that happens, you can get an interrupt, and it also will not swap the buffers until the next game clock. I believe that's the next game clock. So there's stuff like that as well that I haven't quite implemented. What I actually do for the drawing process is I just say, I think that's going to take around 10 milliseconds, which I have up here. And so I just use a counter. So like the drawing period starts, and it'll like raise relevant interrupts and stuff. And then it basically just has a counter, which I believe is here. Yeah, begin drawing process basically says drawing state is in the drawing states. Doesn't actually draw anything until the end. It sets this counter, and then here it's in the cycle loop. If we're in the drawing, if the drawing hardware is in the drawing state, or sorry, if the drawing state is drawing, we're going to update that counter, and if it gets past that 10 millisecond period, we're just going to end the drawing process, and that will raise an interrupt if that's enabled. And that's also where it actually does all the drawing. So I just do it all at once at the end of that period. So that's obviously not correct. And the reason why you can kind of get away with it is most of the games are fairly robust. And they just kind of assume that, okay, the drawing hardware is doing something. Let's just wait till it's done and not really touch it. And that's generally a good idea. I'm guessing that the hardware does work deterministically, but to like try and make like cycle accurate timing that where like you and the drawing hardware are kind of drawing to the frame buffers in like a nice way would be really difficult because of all the different kinds of like bus weights and basically how all that stuff is a little bit more or less non-deterministic. Like syncing all that up would be really hard, so it probably would be a really bad idea to be drawing to the frame buffers while the system was drawing to those. Although one of the ways in which this is bad is it's possible to do like a drawing period that would be really cheap, like way cheaper than, half your frame time, which is 10 milliseconds. And we kind of miss out on any accuracy as far as that goes, which kind of sucks, but could probably make that better. This is actually one of the areas of this platform that hasn't really been explored that much. There's a bunch of documentation that basically doesn't talk about any of these details. And I've seen some guys on the Planet VB forums talking about wanting to do that testing, but I don't think anyone actually has dug that deep into the video hardware, at least. The audio hardware, there's been a lot more exploration, but not the video hardware. Anyway, it seems to work pretty well. But all this is doing is it's basically just going to actually do the drawing here after this drawing period. So we basically clear the frame buffers, one of the things it does, and then it goes through the 32 different worlds or windows or whatever they're called. And those worlds can be made up of, like they can either be what's called a background world, and that's just going to be like a big chunk of 8x8 blocks. Or it can be, there's a couple other modes that are also drawn with backgrounds, but like one of them can do fine scaling rotation. One of them can do like shifting, like scrolling stuff for every scan line. Then there's also an object mode where it's basically going to be drawing sprites. I haven't implemented that yet. I also haven't implemented the affine stuff, but I have implemented that line shift. And it also has what's called dummy worlds or dummy windows. And when that happens, then the drawing process will actually stop. So like the hardware will always go through all 32 windows from the top to the bottom until it hits one of these. And it's just like, oh, okay, done with the process. So you can kind of early out, be a little more efficient. Dero2 says that VS Code, you're not using Emacs anymore. So on Windows, I'm not really using Emacs. I tried to set it up so that it would be comfortable on both platforms, but I couldn't get all the different key combinations that like the custom ones I had set up to actually be comfortable on OS X and Windows. So on Windows, I just tend to use Sublime. That's what this is. But when I'm on OS X, then I'll use Emacs again. And yeah, so all this is doing here is just like for every window, we just actually grab the header from the window offset, which is at this specific memory address. And we just like look at all the different bits, all these different attributes for this window. So I print them all out, and that's what you can see. If I scroll up a bit here, you can see this, for example, is what we get out of that. And this is just invaluable because these are actually very descriptive. It's really easy to debug based on these, like especially if you're gonna like set a breakpoint in the VIP interrupts and just sit there and step frames. It's really easy to see like when these change and be like, oh, there's nothing on the screen. What's going on? Oh, I can look at this. Oh, it's only drawing objects. I haven't implemented that. No worries. Stuff like that. It'll break if it's stop. Otherwise, it will actually do the drawing. And the drawing is done a little bit out of order from what I understand the hardware does. But again, none of the documentation is very descriptive for how that actually happens. So that's just kind of what we live with. Anyway, the drawing itself is straightforward. It's just moving around a bunch of pixel data. And that just draws into the internal system frame buffers. And then there's a display period, which I also do the same thing with. I just say like, okay, there's a certain time with which the display hardware will be like active, and it doesn't actually display anything until the very end. And then it just moves all the stuff from the internal frame buffers into the output buffers, which actually end up going to the window. Ahmed, dude, you're like streaming and stuff. Good to see you again, man. Gaia command, is that what that says? I find Visual Studio Code to be really good for Rust dev. See, that's interesting actually, because VS Code's pretty cool in general. I'm using it a lot at work if I'm doing. We do a lot of .NET stuff, so doing that a lot. Osman, I need to steal some of your Sublime text setup. It's actually super basic. I think the only thing I've changed is the theme, and like a couple things. Yeah, I changed. Here's my whole config. I changed the theme, which is this material design theme. I believe I put a link to that in my FAQ. And then, of course, I have Unix line endings, translate tabs, spaces, stuff like that. Really basic stuff. But yeah, it's this material theme, and you want the dash darker version, because that's pretty cool. Flogeneer, good to see you again. Where'd my console go? There it is. Let me remove this timer breakpoint. Now we're off again. So yeah, generally this thing actually runs, which is pretty sick, and I have some basic input. But there's a lot of things that are wrong, like this little intro here, this animated thing that turns into like an invader. It's actually pretty cool. It actually took a lot of debugging to get that working properly. I just stopped it really quick. But it was, yeah, it was actually really annoying because I think what happens is I don't think it's actually doing software rendering from what I could tell. It looked like it was just copying a bunch of like char data into VRAM at the right times. And so like at what point the drawing stuff and the display stuff were synced actually had to be really correct. And one of the things that was necessary to get that to work right is when the system actually flips frame buffers, I didn't do it at the end of the current game frame. I did it at the beginning of the next drawing sequence. And like, if I didn't do that, this wouldn't work at all. And I thought that seemed a little weird, but it could actually make sense in terms of the implementation on the hardware. Also, it looks like it'll get stuck on a lot of frames here and just like sit there. Usually what's going on there is it's supposed to like scale a logo or something. And I haven't implemented the scaling stuff. Studio C, is there any IDE that supports Rust, or are you just forced to use an editor like Code? I just use one of these more basic editors. But the setup I had with Emacs was really nice with like Racer and FlyCheck and stuff. I think the JetBrains IDE is working out. Yeah, that's what Ashmedai is talking about as well. I know they at least had it in beta. Studio C says the problem I have is that editors work well if the language is like if you haven't internalized already. Otherwise, it spends more time checking docs and function names than actually coding. Yep. Yeah, that's just I don't know. Just kind of chug through it. I totally get what you mean, and it's not ideal. Like I would love to have extra autocomplete and stuff like that, but I don't know. You kind of get used to it. Flosneer is saying some stream bugs, but I don't think they're on my end. Anyway, I had something I wanted to start implementing actually, and I can't remember exactly what it was that I was going to do next, because there's a couple like major things that I know I need to do next. So for example, a lot of these games actually get pretty far. So for example, this one, here's some more logos that should be scaling. Like this screen looks pretty good because we have some like parallax wavy stuff, and that shows that a lot of the hardware is implemented. But like when these clouds clear, you'll see that they don't actually clear, like the background repeats. That's something I need to implement. There's a lot of like the sprites I still haven't implemented. So like if I go to the main screen here, there's supposed to be like these bubble things that float up. Also this monster here is supposed to be rotating. So I haven't implemented that. I don't really want to implement like the affine mode and stuff live just because it'll be really annoying with this smaller screen real estate. So I think I either want to start implementing, actually I think just like the objects, the sprites is what I want to actually start implementing. So I think that would be cool to just do while I'm sitting here. It's already been an hour and a half. Wow. Happens every time. But I'm going to take 5. Get myself something to drink. And then I think I'll start implementing the sprites. So that sounds good. So I will be back in like 5 minutes. I'm back already. That was a short break. But I thought I grabbed myself a little drink, and I also thought that I would grab my sorry, hat gets uncomfortable under the headphones sometimes. Also thought I would grab my Virtual Boy to kind of show you just how weird and awful this thing is. So you can see it's a bit big, like yeah, and it's on these legs, so it looks like it's like a weird. There we go. Looks like a weird messed up robot, and like you would set it down on the table. I wonder if I can set this up. My apartment's a mess, so I kind of don't want to move my camera around. But yeah, really weird. Also, the battery pack is on the controller. Controller's actually really nice to hold generally, except that if the batteries can actually come off if you put it on the table, which is stupid. So I'll turn this thing on. And I wonder if I can actually get the camera to see any of this. Let's just see. Almost. see if I can actually get something on the screen. Sound. This is vertical force. Yeah. Probably won't be able to show it much better than that, but just had to show you just how ridiculous this thing is. But I find it fascinating. Ernest says looks like an old Star Wars droid. It totally does. So do you see that thing looks like it should be studied as one of the biggest UX failures that ever got to real markets. Totally. Hey, Cries, how's it going? Yeah, sorry about like the weird resolution or stream stuff that's going on. I believe that's not on my end because I got a lot of graphs telling me good things. But I guess that happens. Anyway, I wanted to implement these sprites. So this will be fun. Sorry if my window, like working with Windows, is a lot clumsier than it was when I was on OS X. It just kind of is for me right now. Can probably zoom in on this a bit as well. Make this kind of readable to you guys. Move some stuff around. All right. So I want to go over a little bit how I already talked about like how generally the windows kind of work, but there's a couple more details that I want to refresh in my head as well before I actually start going into the sprites. Floengineer says, how many hours have been put into this project so far? I've been working on it for 2 or 3 weeks now, pretty off and on. Like the last couple weekends, I went on it pretty hard. And then this week I've been working on it a lot because I've been off work. I don't know. Like 50 hours or something maybe. That's a pretty rough estimate. But it's an estimate. So not really sure. But it's one of the things that it definitely shows is how much quicker you can get a project done if you're not live streaming everything. So that's kind of funny. M. Stein says, why switch to Virtual Boy Emulator? Do you want to work on a bit simpler system to get through the emulator quicker? Some details in that question I'm not sure about, but I'm just going to answer it like this. What do I want to say? Like, so with Rostendo, especially like with the goal of trying to put everything on the stream, it makes it go just frustratingly slow, at least from my perspective. And this was kind of unrelated to that project, like why I started this one. I just kind of wanted to do this emulator at some point, and I just thought, oh, I got a few weeks between this project and the next project I want to start, so might as well do this. That sounds fun. It is definitely a simpler system, so that's been fun. I guess I decided to do it because I knew I kind of could in a relatively short period of time. Anyway, I don't really feel like it was a switch from the Rostendo project because the Rostendo project was just kind of on hold anyway. And I just kind of wanted to show this today just because I'm working on it this week. And I will probably stop working on it at the end of the week, more or less. I don't know. Maybe that was a bit too much context, but yeah, it's just another project I wanted to work on. But I think, so for those of you guys that that missed the beginning of the stream, I talked about basically exactly what Studio C just said. You should do it in a way that you want to work on your own and just explain the progress in the first minutes of the stream. And that's basically what I think I'm going to do with that project, just because I think it'll be a lot more practical to actually make progress. And like with this project, for example, this Virtual Boy emulator, I was really adamant about having decent commit messages. And I think if I do the same thing with N64 stuff on Rostendo, that I can kind of work on it in a way that's a little more comfortable for me to just work on. Especially now that we've gotten through like a lot of how to get started where all the details were live. I think we kind of have achieved the goal of like, hey, this is kind of how you do this, or at least here's a way you can kind of do this. Where doing all of the rest 100% on stream is actually more of an inhibitor than it is something that's cool right now. So you see, just remember to commit often. Yeah, I tend to have relatively small commits, less so when I was doing the live streaming, of course, because then it made sense to kind of put all those in one. But I mean, also if you look at like how long it would take me to do a commit, like I didn't actually commit that much, and I only did like 12 streaming episodes, even though I feel like I did a lot of hours. Anyway, I think that'll be better because we'll actually make a little more progress with that project, and also then I'll start streaming. Like I want to do every week at this 8 o'clock slot on Thursday evening CET, just to make that super regular and say like Thursdays is my Rustendo day, and then if I feel like working on it otherwise, then I can. I think that can also open the door for larger external contributions to the project, which is something that I really did not want when we were streaming everything. And to some degree, like if someone just implements the coprocessor, or like I can't remember what the name of the unit was, but the little vector processor, if someone just like implements that, then I'm kind of gonna be a little bit bummed to just pull that in. But if people want to say like, oh, I fixed this bug, do this, whatever, then that's fine. And then the stream every week could be like, hey, here's what we did in the last week, and then just banging out some more stuff. So that way it's not limited to just on the stream. And I think that'll just be a lot more practical. And then I hope in the future that we can kind of turn it into even more of like a community-driven project where it's like, here's the Rust and Nintendo 64 emulator. So if you want to work on an emulator, come work on this one. It could be cool. But that's a few steps ahead. For now, I just want to get back on the horse a bit and just kind of make this thing actually happen properly, rather than the past. Actually, it's been like a year. Where I think I dove into it a little too head first, and kind of underestimated how complex the system was, which is a learning experience. Like to do streaming where I hadn't done streaming before, and to do that project where I hadn't done that kind of like emulated a piece of hardware that complex before, was cool to give it a shot with that format in mind. But at this point, I just don't think it's practical to continue that way. But I still want to continue the project, so I think we'll just have to find a way to make that work. And I think that will be stream regularly once a week, work on it whenever, and just go over all the changes. Keep the commit messages really nice so people can follow along really easily. And I think that'll be it. And then that can also double, like, if people are wanting to contribute, then you could join us on the stream on Thursdays, and we could like talk about that with the chat. I know that the actual communication would be a little bit delayed, but especially if someone like if someone's like, I really want to do this kind of bootstrapping, I really want to do this kind of thing, then we should be able to talk about it. And that could be cool. Then people won't like step over each other's toes, which hasn't been that much of a problem, but did happen a couple times. So that's like all my thoughts on that right now. So if you guys think that's cool, then that's good. Whoa, suddenly I can't go to... Something's weird in my browser. Yeah, anyway. So I think that'll be a good way to move forward with that project, which I still want to do. I just want to do it in a way that it's regular. So we'll make that work. Flogeneer, it was really fun to submit bug fixes during the stream. That was one of the most fun things about the Rustendo series. Yeah, cool. And I think like that'll still happen. I mean, like I want to have the ability to like merge pull requests and stuff off the stream as well, just to like move forward with things. But I mean, I'll still go over them. So like, here's what we did last week. It included this change, this change, this change. And then if it's feedback, it just probably won't necessarily be on the stream, but take it off. And then by the time it gets on the stream, then it'll be merged. So I think that'll be cool. So yeah. Anyway, about these sprites. Let me move some stuff around here. Okay. So sorry, I'm still just moving windows. There we go. So it's these windows, at least that's what this documentation refers to it as. Move away 00. I liked being part of the community compiler warning about syntax errors before compilation happened. Yes, and I hope that will still continue to be a part of it, because I think that's really fun. now that you're back from your meeting, you can probably help out with this next bit of code that we'll write as well, because I'm sure there will be small errors. So how like the sort of gist of how this works is there's like these 32 windows, right? They're all like the hardware will basically go through all these different attributes for these windows. Is that H Karayan? What hype? Hey, how's it going, man? So the hardware will go through all of these different 32 windows. It will start like the top of this like area in memory and just like go down all the different windows. So it will draw the 31st one first, then the 32nd, and then the 30th and the 29th, down until it gets to the 0 or until it gets to 1 where it has this stop bit set in the attributes. So if you're just drawing a background, the mode will be 0 or 1 or 2. So 0 is like the normal mode, and it will just draw like based on the X, Y, width, and height, it will select like a window on the screen that it will draw stuff into. And then the BGX and BGY will give it like X, Y, width, and height determine a window on the screen. And then BGX and BGY will kind of move the data pointer around within that window. So you can kind of like display a different part of the background. One of the things that is, of course, very notable here is that it has these parallax fields, which sounds just super dumb. And the parallax is actually how they get the stereo image. So it's basically only drawing 2D things, but it's drawing it to 2 different frame buffers, 1 for each eye. And these parallax are basically a value that will be subtracted from the X coordinate on one eye and then added on the other. And in this way, you get this stereo separation of objects. So if these are positive, it's separated in such a way that the object looks like it's coming closer to you. And if it's negative, then they'll like, go towards your field of vision. And then you get something that looks farther away. Excuse me. So you have that for the X and Y. So it will actually move the whole window around. And then you also have that for the BGX as well, which will, shift it differently within that window. So it's a bit strange, but it actually ends up being very simple. And it's kind of clever in a way, because like if you're just going to draw 2D stuff, you can actually make some pretty good hardware to do that, and this is a decent way to get that kind of effect. But what you end up with is a bunch of games that just look like 3D billboards, which is basically all they are. Big Bad B, how's it going? So this is the format of these attributes that we call for the windows. So these are 32 bytes for all this together. There's this first half word here. It's a bunch of 16 half words. This one is basically enough to determine like what is the mode, whether or not this is to be drawn on the left and or right screens. So like if these are just 2 bits, if neither of these are set, it won't draw to either. If R is set, then it will do if R is set, then it will just draw to like the right one, and if L is set, the other one. Mode will again determine which kind of background it is. 0 is just a normal background, which is basically all I've implemented, except for 1, which is called line shift, and that has another table in memory that it will use to shift all the horizontal lines like left or right with some signed bytes or signed half words. And I did actually implement that. And then BGW and BGH, I kind of want to skip that. Something I haven't implemented. I just want to skip it. Same with this. Actually, this out of bounds thing I kind of should explain. That basically says that if you scroll in a window past the boundaries of the window, past these things that are called segments, which is just organizations of characters, this hardware has like 3 different levels of indirection by the time it actually gets to pixel data, and it's kind of confusing to keep all the terms in your head. So I'm trying to kind of gloss over some of these, but if you scroll outside of the background within the window that's drawing the background, or like when it's drawing the window, you can scroll in the background. And if you scroll past the edges of like the area of the background, it will either repeat the background again, or it will like turn to out of bounds mode. It's basically called. And in that case, it will take this out of bounds character index here and just display that over and over again instead of repeating the background and like looping it. Stop is the stop bit, so it will stop. If this is set, the window will not be drawn, and then the drawing process will stop. And then you have like this base segment stuff, which is part of the address calculation into like where the actual character data and everything will come from. Then again, you have all these scroll values, the width and height of the different window that's on screen. If you're in those different background modes, like I said, what 0 and 1 was. 2 is also like the normal background, but instead of like the line shift or something, it has these basically a 2x2 matrix that you can change every line. It's this big table of the 4 values for the 2x2 matrix for every line. And I might be a little bit wrong about the format there because I haven't actually implemented it, but then that will give you some kind of like SNES like affine transform. And the third mode is that it will draw sprites or objects. And in that case, basically a lot of this gets ignored for the background stuff. And there's some stuff for how it actually goes and finds the sprite data and draws those. And I'm not actually that familiar I'm not that familiar with that, so I'll have to read that. As you can see, there's also these 5 half words at the end, which says VIP scratch area. So the hardware will actually use this as like extra registers. So all the documentation says don't write to this. So don't touch it. It's used as extra registers while the drawing process is happening. I don't know if it's really been studied what it will actually write there and stuff. There's a lot of this hardware that would be cool to study more. Studio, is that Studio Psi or Studio C? I can't remember. I feel like I asked this before. How is the 3D going to be emulated through the use of red blue glasses or something like that? I saw some captures, but I'm still not clear. Right now it's red blue. So if I pull up this little game here, you can kind of see it. So here already you can kind of see that these little emblems in the corner are only being drawn to one of the 2 screens. So that's how I'm doing it for now. Side by side also works, and I mean, if this were a more serious project, I'd also look into like VR, more modern VR stuff. Because I mean, it just produces 2 frame buffers, so then it's like, how do you just composite them on top of each other? And right now, the different color channels is good enough to test and good enough to play for the most part. Side by side thing is pretty eye strainy, but yeah, at least you can see that that's already working. But again, it's fairly simple, just because you basically just draw everything twice and you pay attention to these parallax parameters. There were of course some details with that was kind of difficult, like what is the correct sign for these, and I had like which eye was red and which eye was blue wrong until like yesterday. So there's a lot of those things that you just kind of have to work out, but relatively straightforward. The sprites, yeah. So here's those different mode, different modes. If you go to object, that's the one we're looking for. So I do actually know a little bit about the layout here. Up to 4 windows can be specified as type object. So 4 out of the 32 windows can be specified for this, and there's kind of a reason. Objects end up getting grouped. So an object is basically an interchangeable word for sprite that's used in a ton of these old Nintendo systems. And the thing is that I think the hardware can display up to 1,024 objects. Yeah, here it goes. Object indexes range from 0 to 1023. But you have to group them into 4 groups. And so the reason why you want the grouping is because you're drawing each of these with these different windows, and that determines like the draw order. So like if you have, if you want some sprites above, like kind of far in the background, like if you want background and then some sprites and then background and then some sprites, you need to have those 2 sets of sprites on different windows so that they'll actually get composited in the correct order with all the other backgrounds. So that makes sense. And I guess what you do here is, you can have these distributed by or in up to 4 of those windows. So it looks like it uses these group pointers, 3, 2, 1, and 0, that will just like point to a group of sprites. Now, if I'll use the term sprite and object interchangeably, so sorry if that's confusing, but I will just end up doing that even if I don't want to. So it says here, like the windows, the VIP will draw objects in reverse order, starting with the highest specified index counting down. Objects with lesser indices will be drawn in front of objects with greater indices. Exact indices to start and stop at are specified by the group registers. So here we have different object indices with the bits 0 through 9. So again, that's this range for these 4 different values. And if I remember, so every display frame, the VIP will basically have like a starting object number that it will start counting down at. Like it says, it keeps track of which object groups have been drawn. The first time an object window is drawn, it will contain object group 3. So I guess it's actually just like which group it will use for the next object window. It will start there. Second time it will contain object group 2. This continues for groups 1 and 0. So that's gonna, every time it encounters a window that is an object window, it will use one of these. Either be group 3 initially the first time, and then 2, 0, 1, and 0. And then any after that, as far as I understand, just won't work, and that would make sense. At least that's what I'm going to assume when I emulate it, but that's actually a really good thing to do a hardware test for, but I don't really have the hardware to do that right now. Because I also wouldn't be surprised if it just displayed the 0 one again. That would be kind of funny. Or if it wrapped around, did something weird. Anyway, the first object drawn from a group in an object window is specified by the obj group register that corresponds with that object group. For example, if obj group 2 pointer, or for example, obj group 2 corresponds with obj group 2, and the register itself contains the index of the first object to draw in group 2. Object indexes range from 0 to 123. So already, before I get any farther, I might actually just implement these, just to store their values. I think I'll do that first just to get that out of the way. So we'll pull up the code. And in the, I'm pretty sure these have been written before, so I'm guessing they're going to be already in the memory map. Yeah, so here we have the mapped address for the obj group 0, 1, 2, 3 pointer reg. And I'm guessing, oops, in mod here, these are just going to print that they're not implemented yet down here. And the reason I don't remember this of course, is because, like, especially when you first start emulating this stuff, you get a ton of writes to addresses that you just have no idea what it does. So it just makes sense to just dump them in a big table like this until you actually know what it is. Because you can, especially when you have a debugger like I have now, or even just like an emulator that's just printing all the stuff it doesn't know about, you can kind of start recognizing the patterns of how it accesses data just by like watching the data flow by. Which sounds like it's from sounds like something they would say in the movie Hackers, but it is actually true. Like, you start recognizing the patterns and you're able to debug quite a bit actually just by looking at that stuff. So it's useful to just start like this. But anyway, now that we actually want to implement that, we want to actually have these registers stored here. So these are before like these palette registers. So we'll do that there. Avoid 00. I can see the code. We'll do reg obj group 0 pointer. I'm actually, these are the initial values. I meant to do it up here, which is fine. And we'll make these U16s because we need like 10 bits or something. So 175, I need blondes and red dresses. Good. By the way, like I said, I'm using Sublime, and you'll notice these warnings popped up. This is the, I believe it's called Rust Enhanced, is the package that does that. For those of you guys who are into Sublime and Rust. Yeah. Oh, that just says Rust, but yeah, something like that. Anyway, this is both good and bad. I believe you can disable this, but I generally like to have it on. So now what I'm going to do is all this memory mapping stuff, I'm just going to route to this. I'm actually going to leave it alone and just leave these debug printing for when it tries to do byte access to these. Probably should have done that for all these registers, actually, just like basically disallow those. But again, there were some that actually, I think there were some that were actually reading those. Maybe I'm wrong about that, actually. The ones we want to do, though, is the half-word stuff, so these guys. And this gets pretty simple to implement here because we're just like retaining the values. It's like self reg obj group pointer 0 is value, and then we're going to mask off the bits that we know are not part of this. So I believe it's that, if I look at the thing. 0 through 9. So it'd be 8, 7, 8, 9. Yes, I believe it's that. We're actually going to remove some of this stuff too, just make this a bit easier to read. Oh, and this, was this right? This is read, yeah. So we're just going to, where to go? There. So we're actually just going to return it when we're reading it. The other ones, it's actually just easiest if I do this. Nice. Movie00 would be nice if it didn't include these like up arrow pointers from new arrow formats since visually place there anyway. That might just be me having an outdated version of that package actually. Because I updated Rust pretty recently, but I haven't updated the package very recently. So I agree, but that might actually be fixed. One of those things just becomes something you don't notice anymore. I don't even see the code. So you see that mechanical keyboard? Yeah, this is actually a different one that I use. Well, no, I did stream a couple times from here. Never mind. I like this mic is pretty directional. It's just this keyboard is so loud you can still hear it, but it's a bit excuse me, it's a bit softer now, and I like that. I think that's smoother. Smooth. Okay, so there we have the registers actually being written. I'll also ignore it for the word stuff. As you can see, like this is just a ton of just printing this stuff out here, which is fine. So I'm just going to run the code just to make sure that it still works, but I'll keep it off the screen so it doesn't become the wall of encoder madness. And that ran, so I'm happy enough with that. Again, we're not doing anything with these, so in fact, we might even still get warnings about that. No, because we're still going to return it if they read the value. So, yeah. So that's nice and easy. I usually will actually implement their functionality before I commit. So this will probably actually be a few commits before this actually works. So I'm actually going to start that now, just because. Yeah, I think this will be a few commits before this actually works. So we can do objs. That's what we're going to call this branch. And then we'll do that. So I'm just writing the small message, then the longer message. So I'll write a little bit more information here. Still not drawing. OBJs. If I remember where my keys were. Yeah. So here, for each display frame, the VIP keeps track of which object groups have been drawn. So I want to model that next as well. So what I think I'm going to do is I'm going to make an enum for this. Do it here. Or maybe down here. I'm not really sure. It doesn't really matter. And what I'm going to do here is, what was I going to call this? We can just call this OBJ group. We'll call this, let's call this current OBJ group. I'm torn between whether, you know, here's what I actually want this to do. Never mind. I know how I'm going to do this. We're going to do OBJ group. I don't really like having the name of the enum and the enum value, but when it's just numbers like this, it kind of makes sense. So what we're going to do is we have this OBJ group enum, and we're going to just have, so like I have the registers up here, kind of at the top of the struct here, and then I like have this sort of intermediate state down here. And in this case, actually, since I do all the drawing at once, we actually don't need to have this as part of the VIP. We can just have this as part of the drawing routine, which is down here. So what I'm going to do is I'll just say this. So let current OBJ group, and we'll use an option here. So we'll do some group 3, because we started group 3. And we'll make that mutable. And then here, as you can see, when I do the windows, I go and I read them, and then I switch on their mode here. And if they're objects, I just don't draw anything. And the reason why I did this in particular is because before I just drew all backgrounds as like normal backgrounds, which is correct for 3 out of 4 cases, or at least correct enough. Like it's wrong in terms of like I don't have the affine stuff, but it's fine. But the problem was when you're drawing some of these object ones as like other groups, it had some really like ugly artifacts because like it's just wrong interpretation of that data. So it made a lot of screens and a lot of games look really broken. So I just removed it. Flowengineer says instead of doing object group 1, you can just do like group 1 for that struct. I'm just gonna do that now. I like that suggestion. I'll do that now before I get much farther. Nice and easy. Could also just do this with an integer, but I just think this is nice. The other thing I'm going to do really quick, and this is just for funsies. I'm going to derive debug here, and the reason is because I'm going to do this. So when we get a object background or object window, do this. And we'll just debug print this. So we'll get kind of like the group tracking first. Just do this like piece at a time, because I have a feeling this should be like, this will end up being really straightforward, this part of the code, and then when we get to the actual like data alignment stuff, that'll be kind of annoying, so I'd rather just kind of get this stuff out of the way. So current obj group, we're just going to match this, and we can just write this stuff out. I don't really care. In fact, this will be sum, because we're matching on a option. So if it's like sum group 0, then it's going to be none. In fact, let's do it this way. We'll do sum group 3 goes to sum group 2. Two to 1, and then 1 goes to group 0, and then anything else. Do the catch-all here. It's just going to be none. And of course, I forgot the qualifiers here. Nice. So now if we do that, I want to pull up a game that I know will use these. So for example, I know Wario will use this. Like the first screen in Wario past like the logo screen is just objects. So that should be a good test. So I'm just gonna click through a couple of the screens. That fades out. And already I can see some output. So I'll break into my debugger just to pause it. And now you can see, should show it here. So we got window 31, which its mode is 3, so that's the object mode. And then here we got current object group 3, but then we said current object group 2. And I actually know why this happens. This is because this is a bit silly because I forgot that this part of this loop here, this happens for the left and right eyes. So what we actually want to do is we'll after we do like the left and right eye drawing, which is here after the entry here. Where is it? Because I had the different mode here. And we'll just do this here. If the current window is actually an object window, then we'll do that. And then that won't like decrement twice. Matt RVA said, are there any resources you recommend for learning Rust? I want to use it in my next project, but a few of the concepts are a bit tricky to understand. And Cry said the book is good enough for most situations. Also, there's Blank, which is a video that explains most of the important concepts. If you whisper those to me, Cries, I can share that link. Because I agree with that, by the way. I think the book will get you covered for a lot of stuff. I don't know what other link he's trying to post, but I'm guessing I'll agree with that as well. Indorust.com. Yeah, I will definitely stand by that as well. That was the link he was trying to post. Now, I'm just going to break this again, and here it prints the current object group twice. But that's okay, because that's correct. So this was printing it, once for the left eye and once for the right eye, but that's fine. I'm thinking, though, this will also do the iteration for each one. That's probably okay, though, because it'll be the same. So we can just do the iteration twice when we do go through the different objects. That should probably be fine. And there might be some other code that I'll have to move around, like when we actually start reading pixels, because I'm guessing it will share like all the code from, like I'm guessing by the time we do enough indirections to actually get into character data and some of the scrolling stuff as well, I'm guessing that will be pretty much identical to the code in the background that's doing that same stuff. Also, you'll notice that I'm doing a lot of stuff like in the per pixel code. And that's just like trying to do it correctly first and then optimizing later. It's fast enough, at least on my machine for now, which is good enough if I'm just trying to learn the hardware. Phil's Near saying the best way to break into Rust, in my opinion, is to treat it as C and then Google the problem whenever the compiler yells at you. It's not perfect, but it helps contextualize what's important and what's not. Yeah, definitely if you come from a C background, I could see where that would make sense. I think I actually learned a lot of it that way as well. And just making stuff. Gotta make stuff. But that's obvious. Anyway, so now we have like the group tracking. I'm just gonna commit that even, like just to keep this super compartmentalized, at least while I'm just like splatting the feature together. I'm just calling that group tracking, which I think is a pretty decent name for that. By the way, about like link posting, I know that I have it like blocked, but I'm wondering if like if I had any moderators, would they be able to post links? I don't know that much about Twitch. Okay, so now it's saying that it will draw objects, decreasing the index, the object index, which it will first get from the group pointer. by 1 every time for as long as the current object index is greater than the index specified by the next obj group register. For example, if obj group 2 pointer is set to 123 and 1 is point to 45, then group 2 will consist of all objects from indexes 46 to 123. That makes sense. So we're basically going to loop from the current object pointer inclusively down to the next object pointer non-inclusively and draw all those objects. I'm going to be doing a lot of just like kind of printf debugging as I'm working this out, just because, like I said, like this stuff is going to be relatively straightforward, but we need to absolutely know that it's correct and predictable by the time we actually start. By the time we actually start poking pixels, because that data alignment is going to be pretty precise. And it's really easy to like mix that stuff up. Like if you miss a shift or something, it's super easy to mess that up. Flows says, pretty sure mods can post links freely. Cool. If anyone's interested in becoming a mod for my channel, you guys should whisper at me or something, or yeah, get in touch with me somehow. I won't promote anyone on the stream, but we can talk about it after then, if you guys are interested. Because then there's stuff like a situation like this where it's like, it would be easy to just have one of you guys do that. Studio Sai says, Rust has a backbreaking learning curve. There's not a lot of so common concepts. I would get into Rust, seems cool. So I actually agree with that. Generally, I think that Rust is actually a bit harder to learn. So to be fair, I have a C background. So like, I think Rust is more complicated than C. And I think in a lot of ways, that's just kind of objectively true. But it's also a lot more rigid. Like the reason why I like using it is because the compiler yells at me a lot, and I can just I can bumble a bit more and just like feel better about it than I do in C. Even though I think, especially with like borrowing and like how references work and stuff, it's a little more concepts to learn. Like I imagine trying to learn Rust and not knowing what a pointer is and just getting very confused. And that's a bit unfortunate. And maybe that's just me speculating wrong, but yeah, I just think it'd be kind of complicated. Just gonna change my song. One second. It's important. Yeah. Okay, so what we want to do is we're going to go through the current object group, and then we're just going to actually do that loop. Flosioneer says, yeah, Rust is terribly hard to learn, but the compiler's a godsend. I more or less agree. I don't know if I'd say terribly hard, but I do think it's harder than a lot of other things. Compared, like it's not hard compared to C++, you know what I mean? But I do think Rust is kind of hard to learn. But I really like what the language does, and I really like how the compiler helps me. So it's a tool that I really like to use. So you say it's good the dev team noticed that. Yeah, the Rust devs in general are really good. It's an awesome community as well, which is definitely reflected by a lot of the viewership of this stream as well. A lot of really cool people. Yeah, so this will be fairly easy. I'll just, since I actually don't remember if Rust had a shorthand for like looping backwards, and also just to make sure that we get the right non-inclusive looping, I'm just going to say we're going to match the current OBJ group. Oh, cries. Oh, you can use rev. Yeah, of course. But then I'll just have to add 1 to both of the indices. That's probably worth it. We'll do let yeah, I will actually use the iterator with the rev there, because I'm guessing that'll be optimized. Although I will need to add 1 to both the indices in that case, I think, just to make sure it ends up being inclusive in the right range that we want. Because we want to include the upper bound and not the lower bound, which is backwards how it normally is. So the starting OBJ index is going to be match current OBJ group. And yeah, OBJ group. Getting distracted. Yeah. We'll do it as usize here. Actually, we'll do it at the end. The end of the match statement. Match expression, sorry. And I'm guessing... Whoa. Oh, yeah, of course, because we need... Right. What we'll do here... we're going to actually do this. We can do some debug printing on the other one to show that we had some wrong stuff. So that should do that, and then none is not covered, which is what I wanted because, oops, we actually don't need those there. We'll do something like that. And that. Yeah, that's actually fine. Whoa, yeah, because we moved that there. Oh, we move it here, didn't we? So we can do let's do ref here, I think. And then these need to be references. Let's make a copy. I think that will fix the issue. There we go. Yeah. And for the ending one, we'll assume both of these values are inclusive. We'll do the same thing. So for group 0, I think we just end up being 0 here. Against group 0 pointer, because these are like off by 1. H Crying, personally prefer Nim. It's a nice flexible language. Nim is one of those ones that's on my list of languages to try. Rust just does everything I want in the way that I want to do it. So I got stuck there. Yeah, so then we'll do for we do actually want the index. So we'll do because that actually should include object 0, right? Let me double check on the details here. If the next group has a value greater than or equal to the current OBJ group register, if the current OBJ group being drawn is group 0, then all remaining objects through index 0 will be drawn, actually. just to make these inclusive, we'll do this here. Yeah, that makes sense. So then we're not covering the case that this would be greater than this. But we can just do that here. Let's just do this. This will be nice and easy. Yeah, easy enough. And then we should be able to do this will be inclusive, and I think we have to add one here so that we won't actually get that. Community compiler is your time to shine. Let me know if that's correct. I'll just draw the index here for now just to make sure I just want to look at the iteration, make sure it looks correct. Gonna do a lot of debug printing and then just remove a lot of it. Leave what's still helpful, which I'm sure there will be, especially because like this is not that much printing per frame. If it's like reading a register and it's like in a loop, then there's going to be a lot. But at least in this case, like we know that there's not actually going to be that much. Because it's like at most a couple thousand of these. Okay, that is actually probably a lot, but we'll see. In this case, we get the current group is group 3. The current object is object 0. And then that's it. So I wonder... Oh, hey, check this out. Attempted write word to obj group 0 pointer reg, and then attempted to write word to obj group 2 pointer reg. So I guess this is actually trying to access these with words, which is a bit dumb. Shouldn't be doing that, but I'm guessing that that's going to be correct. That makes sense why we're only getting current object here 0, which seems a bit odd. Just trying to think. This is little endian, so this would have been group 0, group 1, group 2, group 3. No, that can't be right. This is the max value. Would have expected 0, 1, 2, 3. And I doubt that that's crap. Let's just implement that though. I don't really want to implement like the right word here. I would rather have had some way to just always make all the registers access these values here. So I might just do write the words in this case. It'd be kind of a hack here, but I haven't seen any other registers that do this, so I'm probably just going to do this. Do that. Actually, this would work for basically anything except the VRAM. Well, it'll work for actually anything. which is actually probably not a bad way to just implement this. Now that I think about it, might actually do that because I think the only thing that was actually writing words like this was a VRAM. And as far as I know, it is actually pretty correct to just do this. In fact, if I really wanted to be like that, I might as well just remove all the word access from this anyway and just emulate it as half word access because that's, as far as I know, how it's going to be anyway. I think that's pretty true to the system, if I remember reading that correctly. I think it only has a 16-bit bus. So I think I'll do that. I think I'll just remove all the word access stuff from here and then make the interconnect deal with it, which I think is going to be, I think that's sensible. So do that. Do this. Whoops, there it is. Yeah, I think that makes sense. And we'll basically do the same thing for right word here, but it ends up being a couple steps. Do that. Just to make sure I did that right. Yeah. Okay, I think that's good. And I think the byte access should probably have also done that, but I think this is fine for now. Where the byte access would have actually read a half word. You know what? I might actually just do that now. Because I'm fairly certain that that's how that works. And that would allow me to remove some duplicated code here. LED brightness. Yeah, I'm going to do that. Get rid of write byte. We'll get rid of read byte. Technically, it might make some stuff slower, but I don't really care. Because I don't think it'll be incorrect. And I think that matters more. In this case, it's plenty fast already. So let's do it that way. The only issue is that if this were reading byte, the alignment might be a little off. Flows near deleting 100 lines of code is so satisfying. It really is. So what we'll have to do is we'll do this here. Do that. In fact, I think this actually does it already. We'll do that for us already, but we'll do it here. Oh, excuse me. So we'll do half word and then we'll do this. Just check this last bit. If it is 0, then we'll take that first byte. Otherwise, we gotta shift it out. So that'll make sense for the read. And the write, I'm guessing, will basically do the same thing. Yeah, that looks good. I'll do that. Half word is if so it's on the byte boundary, then half word is just going to be value as this. Otherwise, value as, we actually have to do U16 there. Shift left 8. And then we should be able to do self VIP right half word. And we'll do adder and the FE and then write the half word. I did mean value there. And there we go. So I think that will cover that. And if I run this again, waiting for it to compile. Oh, that was fun. Check this out, guys. So this is the new loading screen. So I'm guessing... Did I write both half words when I'm writing a word here? Yes. So maybe when I did the byte access, because I think the byte access still writes both of these. So we'd get like on the lower byte access, we'd get like the like it would write the regular byte, but then on the higher byte, it would actually overwrite the lower byte just because of the half word it's writing here. So I think we need to fix that. This is correct in this case when we're writing the word because we actually have all the information, but it's write byte that's incorrect now. And read byte, I think, is also correct because it'll just read more data than it needs, and the half word stuff is fine. So it's here when it actually writes the byte. We either need to reintroduce write byte, which I don't want to do, or we do a read here, which I'm kind of leaning towards that. It seems a bit weird because I'm fairly certain that all these registers were 16-bit, but maybe the VRAM actually wasn't. Maybe it did actually have like word and byte access to the VRAM and just had half word access to all the other registers. In that case, the correct way to model this is to bring back those other write functions here, the read and write functions here, and then do that extra translation as part of the VIP, which is not that bad because it's basically just moving this in cases like this, and in the other cases, then we actually just get don't have to do anything hacky to get around the fact that that was wrong. And then for VRAM, we just let it pass through. So I'm actually going to do that, I think. I'll start just by undoing this deleting of all this code. And then that's fine because then we'll only take the VRAM and the unrecognized adder stuff. And everything else we'll just interpret as, yeah, whatever we needed. I think that makes sense. Yeah. So then here we can just again do write byte here. Yeah, I think that works. I think I'm happy enough with that because I think that makes sense. I think that's what the hardware is generally doing. Except then I think this is still wrong. It actually won't be in these cases though. So then we always get half word access to all the registers. And then we get the correct address in VRAM. I actually think that this works. This works for me. So let's stick with that. And then we'll basically do the same thing for read byte that we did here. And I definitely know that like the addressing here is going to be correct, because if I recall correctly, all of the VIP registers were aligned on a half-word boundary. So I think we're okay there. I'll double check with the docs in a second, but I'm fairly certain this will give us what we want, except this. So also this kind of code wouldn't work if we did like bus weights and these like read half-word thing methods, but that's not a problem we have to deal with right now. And I'd rather not try to solve problems we don't have. But I mentioned it for completeness. So actually, these are aligned to word boundaries in this case. No, this is half-word boundaries. This is correct. So that's good. And then again, we still got to delete a lot of code. Let me just diff this really quick to make sure that that was sensible. We didn't really do anything we didn't mean to. Looks like read word still isn't being used. Or did we not put that back? I think we just didn't put that back. And then it's fine. That's a nice change. Does anyone remember, isn't there like an interactive commit thing or interactive add or whatever it is? Does that work? Let's see me bumble through this. Let's not do that. Get add-p. And then I just like yes, no through these, right? Because that way I can separate this bus change stuff from the other stuff. And you guys are on top of this. Patch mode, that's what's called. Nice. Yeah, we don't want that in this patch. We do want that. We do want that. We do want that. We don't want that for this patch. Nice. Yeah, thanks, guys. This is nice. So all we did was simplify stuff. That's pretty cool. And we'll do another git diff for the other stuff just to make sure they're separated. And now we can just commit this. Before I push that, I'm going to close near. That's cool. Yeah. One of the guys I work with showed me that, and I always forget what it's called, but I really like that feature. So now I'm just going to run this before I push it just to make sure that that actually was correct, which I should have done before committing, but that's okay. That's what Git's for. That's why we distribute our version. That's why we have distributed version control is what I wanted to say. Okay, so now this actually looks correct, and I'm guessing basically everything about this is correct. Because the fact that that showed up at all means a lot of things went well. Cryo says, keep in mind that this only it only does this stuff for stuff that's already indexed. No new files are part of -p. But could you like add a file and then do -p and then like patch what's added? Does that work? Because that would also be enough to cover a case like this. So now you can see that these start at group 184, or yeah, 184, and then they go all the way down to 0. That still seems a little bit much, but yeah, let's just see. Let's assume that that's correct. I'm just going to push the bus change that we just did. And again, I'm pretty sure that that works because things would be very, very broken if that was wrong. In fact, I can run another couple ROMs just to make sure. But I don't think this is necessary. I think this is just peace of mind. Like the fact that we basically get anything on screen is a really good sign. And now we basically only implement all the registers as half words, which is really good. Makes sense. I always like when these games have cutscenes. Watching a cutscene in your emulator always feels really good. By the way, if any of you guys have ever done any 3DS homebrew, talk to me. I think it'd be pretty cool. Especially if you guys have tried that in Rust. I know that Cries has done some Wii stuff in Rust, which is pretty cool. I guess it already has the target triples. Because as far as I know, at least CPU-wise, it's some little ARM CPU, but I really don't know the details about 3DS. This would be a really cool target to port something like this to. And I'd be very interested in looking into that. Anyway, so yeah, so that works. Also, Cries confirms that if you do an add and then go into patch mode, the things you added are indexed, and you can like add and remove bits of the files you added. So that would work. So that is really nice. It's called patch mode. I got to remember that. Gaia Command says 3DS is OpenGL, right? I don't know if that's actually the case. The thing, especially for homebrew, because as far as I know, like it would the homebrew scene would need their own OpenGL implementation, I think. Move Away has put a few dots on a GBA screen in Rust, but that's about it. That's still pretty cool though. That's a system that I'd be interested in. Cries says I don't think it's OpenGL. Yeah, I don't either. I think it's some proprietary stuff. But I think the homebrew scene has gotten pretty far in terms of like understanding the command list and stuff. So I think, yeah. I don't know. Check out the Citra project. There's probably some details there. That's not necessarily homebrew. That's a emulator, but they'd probably know a lot of that stuff. I guess that would be lower level than like OpenGL anyway, but I don't know. H. Karian, apparently the Switch supports Vulkan. That's rad. Getting distracted. But I looked a bit into cross development to try and get Rust running on the Virtual Boy, but because it's definitely not this processor is kind of obscure. I think there are LLVM backends for it, but I think you really have to like build your own stuff for it, and it was a bit too deep for what I wanted to do that one afternoon. Anyway, at least we're looping through a bunch of these objects. So now what I want to do, it seems like we're looping through a bit too much of these. So like if I show you, oops, let me get to the right thing. Sorry if it's annoying that I keep moving the console window. I just don't want it to freak out the encoder. Crisis, if they have LLVM backends that work, that shouldn't really be a problem. The issue that I had was that I had trouble like because I saw the string NEC v810 somewhere in some LLVM code. I didn't see it on any like supported list of LLVM backends because I don't really know where to look for that. So I had trouble finding out whether or not it was actually something that was supported by LLVM, and two, how I would cross compile that with the Rust compiler. And I found there was some cross Rust GitHub repo somewhere that gives you a lot of those details, but it's all explained in terms of like, oh, I have this target triple already, and I just want to compile Rust to this target here. Anything beyond that, I just was way beyond my familiarity with LLVM and the Rust compiler. So if you have any tips, I'd be interested, but that's as far as I got. Looking into it pretty briefly. Anyway, what I was going to show you guys. Also, Christ says, I put a 6502 back in Rust LLVM fork and it worked. Oh, that's pretty cool. Deadbringer says DS is an ARM11 ARM CPU. Yeah, ARM11 CPU, so it should work. Yeah, that'd be rad. H. Crine said, this might be somewhere to look with a delete link. If you whisper it to me, I can at least screen the link. But the Rust 3DS template, cool. Hadn't heard about that. I'm gonna check that out actually. Yeah, project template for Rust projects to be built on the homebrew Nintendo 3DS homebrew launcher. Star. Oh wait, this is a fork. Rust 3DS apparently is the original. Star that one. I'm gonna paste that link really quick. Flosioneer Zargo is helpful for cross-compiling onto bare metal or exotic targets. Haven't tried it myself yet, but I want to use it for Rust development. Uwe and Kreis both then say Zargo is awesome. So that I do remember that's what I was looking into. But I think as soon as I found out I had to set up LLVM on Windows, I kind of just like, eh. But I would be interested in digging into there further. I just lacked a bit of direction. So again, if any of you guys know where I might find how to figure out like what target triples are actually supported in LLVM, so I could actually see if this was a real supported target or not, and also how I might go about actually using Zargo, unless once I figure out the target triple, everything else is covered in that cross Rust thing, then I guess I'm good to go there, but that was a missing piece of information. Anyway, so now this is looping through the current objects from 184 all the way down to 0. And actually, that kind of makes sense with the register values we saw earlier, because we did see like a 184 and then like a 03FF, which would make sense that would then just loop through all these. And then, yeah, I still think that's a bit much, and that seems a bit odd. But what I want to do now is assume that that's correct, and then start like parsing all of the different, like the next bits of these object tables, just to see if the data that we get out of that actually looks correct. Chris's main LLVM only has a few targets. Definitely not whatever you have here. You need to merge that in, but like I said, I know how to do that, so I could help you with that. Yeah, that'd be really cool. I'll make myself a reminder to, I guess, I'll DM you on Twitter or something if that's a good way to reach you. Because I'd be interested in looking into that. Like, I don't want to spend too much time with Virtual Boy come the new year, but I definitely want to dig into that a bit just to see if it's possible. So I just set a reminder to do that tomorrow. Sweet. Okay, yeah. So what I want to do is I want to go to the next part of these tables just to see if the data that it's actually pointing to would actually make sense. Additional object windows can still be used because VIP starts drawing objects at the value specifying the OJ group registers each time. Object windows after object group 0 have been drawn during one display frame will not have any effect. Errors note, is this correct? We're going to assume that that's correct. But then how will it draw these? That's drawing procedure. We already know that. I'm guessing, yeah, okay. Just clicked a little link there. the actual objects. So objects, also known as sprites, are graphical elements that are used to display characters, arbitrary locations. This contrasts with the background, which can only display characters at a fixed 8-pixel interval. The trade-off is that objects require more memory per character and take longer to draw. Okay, yeah, so we have an object attribute memory, which is pretty typical for these kind of systems, just have like a dedicated memory address where like this is where objects are. That also makes sense because we had 1024 object definitions, so I'm guessing those are just going to be however long this is, in this case 8 bytes each, and those are all just going to be linear in this address space, which, judging by this, looks correct to me. And here we have assign X, we have the LR, we have parallax, assign Y, palette. Okay, so these are literally just characters, which is great. It looks like it'll just draw full characters. Whatever their palette is, if it's going to be drawn left and right, we have the parallax. Kind of cool how this is packed. And then here we had the actual character index, which is 10 bits. Yeah, so this actually looks lovely. I'm just going to read through all this just to make sure that that's not crap. This also says assign X coordinate in pixels of the top left pixel of the object within the parent window. That seems strange to me because if you look at this, if we scroll up, the window itself is here. And you'll notice that the width and the height of this window are both 0. So when it says that this is within the parent window, that seems a bit odd. So what I'm going to do is kind of ignore that and just say that this is just where it's drawn on the screen. It could be possible that it uses like the X and Y coordinates of the window to offset all the sprites, but that I'm not actually sure. I'm not sure if that's what this means. Let's actually go to the window just to see if it mentions that. There are some other documents that I can confer with, but not on the stream. Yeah, I'm going to ignore that for now because it doesn't say anything like that explicitly. And if that's it, I think it'll be obviously wrong if we run into that case later, and that is actually how it is. Anyway, so then all we actually have to do is just draw all of these characters. That should be nice and easy. Yeah. So let's first just like parse all this data. Just read it all from these tables. Here. Again, we're just going to print a ton of stuff for now, and that's going to be fine. I'm going to move this off screen. Or actually, can I make these left and right in a comfortable way? Nope. I probably just scroll back down there. Because this is all we really need here. This is the problem with these, with streaming. Yeah, anyway. So, like what I did here for the backgrounds, or for the windows, the normal windows, is I just like read in a bunch of the data like this. And I'm just going to copy some of this because I'm lazy as hell. And I at least know that some of these are still going to make sense here. Because this is what we want to do. We want to basically just print out all this stuff. The other thing I'm going to do is I'm going to take the, like, we're going to get an offset for this particular object. So this is going to be this offset in memory. So we're going to do, it's going to be 0x 0, 0. Now just to be sure, I want to look at my memory map really quick just to make sure that is where I thought it was going to be. So I don't have to do any more remapping. I'm being kind of lazy with how I'm doing the memory lookup here. M. Stein is saying Windows key and right arrow to align the window with the right side of the screen. The only problem with that is that I'm actually on a 4K monitor and I'm using the top right corner of the screen, and those hotkeys don't work within those subregions. So like if I did that, you'd see the top half of the window. So normally that would be very helpful, and I appreciate that, but fortunately it doesn't apply to this case. What was I going to do? Yeah, so I just wanted to check the memory map here, which is like right at the top. Memory map. Yeah, so this is all contiguous. So this will be in my VRAM here. It's Korean says 4K monitor, nice. Yeah, it's 43 inches too. So it's so nice. All the screen real estate. Which is actually great for streaming because it's like I have the code, and then the documents, like what you see on the screen, is my top right. My bottom right, then I have the terminal. My bottom left is OBS, and then the top left is Twitch, like the dashboard and the chat and everything. So it's actually really nice to just have it all on one screen. And Stein, I used to just do the whole screen, but since I'm on Windows now and I have this 4K monitor, then, and it just makes sense to do one of the quarters. Anyway, so that'll be the offset into the memory here. But then we're going to add the character index times 8. And that should give us exactly the offset here. So we're just going to use that here. And I think that'll give us mismatch types because it wants to be a U32. And honestly, what I'll do there, I think, or found U16. Yeah, because all these were U16s, weren't they? Let's just do this. Let's just do add U32 out here. That's fine. Alternatively, I could have done the as U32 here, which I actually kind of like. Yeah, let's do that. So then we have the object offsets. So X is actually this. Parallax is going to be this with some different bits, actually. And I wonder if that is... Yeah, assign X horizontal bias for the parallax effects. So, because it looks like this actually is missing a couple bits, so we're going to have to mask those out and then do a sign extend, which, unfortunately, because it doesn't fall on like one of the 8-byte boundaries, we actually have to do it by hand. But that's not that bad. Yeah. Also... I just noticed that the window has different L and R values than the object. So what I just noticed is that in the window there's these L and R flags here, which is whether or not the window is going to be drawn on the left and or the right screen. Actually, maybe that makes sense in this case. Let's go back to window 31. Okay, yeah, so these are still both turned on. I'm guessing these still need to be enabled for it to actually write there. MoveAway00 says you can shift it over and then convert it to a signed type and then shift it back. That's actually not a bad idea anyway, just because it'll also mask off the other stuff. So I'll probably do that, actually. Also, this needs to be a +2 here. Like, one of the earlier moments when I was working on the drawing stuff, I could not figure out why all the data in the window memory looked just completely wrong. And it was because I made a really fun mistake. And instead of doing like +2, +4 here, I did like +1, +2. So I had all this misaligned data that I was reading, and that was really annoying. Wait, 00, he said, or maybe that's what you meant by manual sign extend. Well, I was going to do something else. I was just going to like check that bit and then actually or on some values. So this is another way to do it manually, but it's a way that I like better. Also, I really don't mind just hitting VRAM twice in this case. So we're just going to do like L and R separately. Or we could do let L, R, parallax is this, and then we could say let L is L, R, parallax, and just whoops. I'll do something like this for R. And then for the parallax, we'll take LR parallax. Shift left 2. Nice. As long as that's sign propagating, and I think it will be. That's pretty nice. I think these have these spaces in front of it because of the way I was printing stuff, but that shouldn't. I think that'll still look good here. Just a little bit easier to read. And then we'll read the rest of the stuff as well. But I think wait a minute. I might not actually be checking those left on and right on values anymore, which is kind of silly. I did some refactoring of this today, so I wouldn't be terribly surprised if I messed that up. Oh no, I do it here. Okay, that's probably fine. That's probably fine. Because we'll do the same thing here. Not the most pretty code, but it'll definitely work. And at least it's fairly straightforward when I fix the indentation. So I'll just skip this object. Yeah, that's all right. Anyway, let's get the rest of this data out. Do an ugly thing here again. Yeah, 0246, that's our 8-byte alignment there, so that's nice. Do shift right 14 there, don't need to do any masking. HF is... So HF and VF here are going to be the horizontal and vertical flips for the tile. Really common for this kind of hardware to be able to do that. And it's actually a pretty nice feature because, like, especially if you do like a border tile, be nice to be able to like flip that and have it work for basically a bunch of different directions. So that's why that's nice. And for the hardware, it's really not much different, just how you count the bits. By the way, speaking of hardware, I was watching a really interesting talk from the 33C3 about some guy who was doing what do you call it? I have it over here. Formal verification of Verilog HDL with Yosis SMT-BMC. I'll paste the link. Basically, for those of you who have no idea what I just said, and not just because I mumble a little bit, but Verilog HDL is a hardware descriptor language, so that's what you do to like design hardware. I mean, if you're not doing it by hand discretely, or with discrete components, but basically formal verification is a way to like, you can almost think of it as just making, I actually think there's a lot of parallels to dependent types in programming, but I mean, in the same way that like types are part of the formal like proof that is your program. This kind of like gives you a mechanism to like formally prove that certain things, certain assertions about a circuit that you're designing will always be correct or will always be incorrect, for example. Just as a way to verify your circuit more than just like testing it, like, because there's also like a test bench with simulation approach as well, which is pretty nice to cover a lot of cases, but it's even better if you can say like, oh, hey, I need some tool that I just want to make sure that this line always goes high when this line is high or something like that. So it'd be really cool to have those kind of tools. And of course there are like, if you guys are familiar at all with that kind of space, it's like, there's a lot of really good tools and they cost a lot of money. And like, if you just want to like buy an FPGA and synthesize some basic circuits and just run it on there, not a problem. But if you want to do this more advanced stuff, you actually really have to start selling out cash. So not a lot of people actually have access to tools that are similar to what this guy was doing. So it wasn't necessarily that what he's doing was particularly novel, but the fact that he was doing it open source was really, really cool. So that was pretty nice. Lagerche 64, I think I read that right. Yeah, working on Virtual Boy emulator. I believe it says up there. Anyway, this is going to be yeah, not working on Rosendo today. I think I'll start working on that again next Thursday. And then we'll do let char is, we can do char index. Then that's actually the easiest one. I think I got these wrong, by the way. Yeah, because this is, oops. 20 and 10, isn't it? Yeah. That's correct, right? Yeah. And then we can do, just print these out as well. Index. Requires that rightward drift, yeah. It's pretty deep. And the only reason I haven't like fixed that, I tried doing that earlier with the background stuff, but it was, I had to pass around so many parameters because a lot of it was just specific to this one drawing routine. So I just said, screw it. Would be nice to do later, but yeah, that annoyed me. So this is interesting because we're getting a lot of characters with the same index, which means it's deliberate. Like these were definitely set like this, 26 for sure. And we do have, looks like different X coordinates. So it looks like this is some like tiling background or something. That's pretty cool. And here we had some other different characters. So although it seemed weird that we looped through all these characters, this data actually looks pretty sensible. And that's nice. Also, it's printing out so much stuff now. So earlier me who said, oh, it's not that much, was totally wrong. But we're going to keep printing it because this will be really invaluable for actually getting this to work. Just going to diff this again. And I'm just going to, instead of doing the patch thing, I'm just going to remove this and then add it back in a second. Start parsing OBJ attributes. Push that. And then we'll just add that back in. So we know, this is if we know it's going to be drawn. What we want to do is actually draw this. So just want to look at the other code I had on here. I might actually even just copy some of this, like this char offset stuff I did here, which I'm not particularly happy about, but I can reuse a lot of the variable names here as well and just make the code nice. Yeah, so like offset X and offset Y is what I used for this, and I even have the vertical and horizontal flip there. So what I'm going to do, let's just do this. And this is the kind of, like, again, it kind of sucks that I'm just copying and pasting some of this code, but until I know it's correct, I don't want to try to reuse any because that's just going to slow me down. If we have 2 working pieces of code, then we can refactor, but until then, it's better to just do this. At least I think so. By the way, X and Y here were signed. I just want to make sure we interpreted that correctly. I believe we did because there's 16 here and 16 here. And we had the parallax here as well. So that should be fine. Anyway, this we're actually going to want to loop. Like that. And through masking, we can just reset these in the loop. Which would be easier than like having different loops or something. Here's that more of that right drift, but that's all right. This will be a bit ugly for now, but I think it'll be all right. And that'll cover this instead. So that's our offset, and then we'll do our pixel positions within that as well. In fact, we can even do the pixel position here even. No, because we'll just do this. We'll do let pixel y is y plus offset y. If pixel y is less than 0 or pixel y is greater than or equal to the frame buffer resolution y. The frame buffers actually have a different resolution than the display resolution. The frame buffers actually extend a little bit below the bits that are actually displayed. And I think it's more correct to still draw there. Even though this won't be displayed by the display hardware, I think the drawing hardware will still write down there. So I think it's correct to do this. Anyway, we want to continue if that's the case. And not draw this row of pixels. Of course, this is I16. Yeah, we can just do as I16 here. We'll do the same thing for pixel X, which we'll do here. Again, this is getting kind of ugly, but it always does when you're just moving around pixels. And that's just how it is. Yeah, in fact, we can do this before we actually calculate. No, we can't do that before we calculate the offset. So this goes above here. And this will be pixel X. So if we get here, we know that this is, we're actually going to draw the pixels. So we'll do all this stuff In fact, quite a bit of this actually. I know it's total crap that I'm just copying and pasting this, but I just want to get it to work first. So please excuse that. This code gets pretty deep. So what I'm going to do, we can calculate this char offset first. We can do that out here. And that's the offset of the character data in memory for this particular character. Which is why we use the character index here. There's a little bit of extra memory mapping that we shouldn't really have to do, but that's what we're doing. And I think what we actually want to do here, I think instead of making these I16s, let's actually just do them as U16s. Which is fine in these cases. We can just do everything unsigned. The only difference is here. Because keeping everything unsigned just keeps some of this a little more consistent. And it should still be correct because of 2's complement. So we should still be fine, except here, let's cast the char index to U32. In fact, why are these U16s at all? Can't we just do like this and it'll all be U32s? Oh yeah, because I did X and Y here. So the way we can do that, we can, if we make X and Y, in this case they were 60. What did I do down here? Because I'm pretty sure I just, or in the window stuff, I'm pretty sure some of those I kept as U32s and some of those I had as I16s, which is fine. Some of these I casted. I think when I started actually calculating like the character indexes and stuff, I just started casting everything to U32s. Yeah, that's what I did here. Which is fine, because if you'll get the right sign extend if you do that. You cast like an I16 to U32. So I think I'm going to do that. And that was, yeah, that's actually another important thing here anyway, is that we need to do wrapping adds here. And then everything should make sense, except I don't know if it got the integer type here. So let's see if we can do this. See if that will infer the type. Maybe it didn't. Can we do this? Let's do this. Oh, okay, no, it wasn't complaining about that at all, was it? Let's do that. Let's put that back. It was this that it complained. We can do that there. Good. And then here we'll do SU32 as well. Right, and then here the comparison uses the type limits, which is absolutely correct. And then this is still valid, because it would have wrapped around if that were not the case. And that's pretty good. So then we have everything as U32s. So we'll get the char row offset. This still makes sense because like it has to do with how the characters are laid out in memory. So we're gonna take the row based on offset y, which is multiplied by 2 because it's 2 bits per pixel, so it's 16. Or sorry, it's 2 bytes per row of 8 pixels. So that's why we take off this plus 2 plus the character offset, which is correct because that's going to be the offset of our character in memory, plus the y coordinate, or like our offset y in the character, times 2. That'll give us the row data, and then we can read just that row. And then here we're going to look at the palette index there. Based on the palette that we read from here, we're going to look that up in different palettes. This is now wrong, though, because this needs to be the object palettes, which I believe work exactly the same way as the other palettes, as the background palettes. So we had a lot of stuff here that was duplicated, but I think everything else still just works because we use consistent names here. And I think that might do it, at least for the initial implementation. We'll want to try and merge some of this later, but for right now, I think this is fine, especially when we have a very limited view of the code. So if I hit enter, things will move very slowly, but it looks like we actually drew stuff. And that's really cool, except that some of this is very clearly wrong. And it looks to me like this is the like horizontal or vertical flip breaking. Like if you can see here. Just because I'm curious, I'll also hit enter. You'll notice it's going really slow because it's printing out all this information. Yeah, so here, as you can see as well, it looks like the vertical flip is not working correctly. See that? So I'm going to try and fix that first. I wonder if that's just that... Oh, I know why. Because this uses the same offset. So it would have flipped it vertically, but then we also would have drawn it upside down. So that's wrong. This is kind of nasty, but this will work. Again, I want to see this working, and then I want to clean it up. Whenever you're just sitting here moving pixels, it always gets like this. And this would have covered both of the flips. They both would have been wrong in the same way. And that actually makes sense to me, that based on the bugs we saw. So now this screen should look correct. And it does, which is awesome. So that's actually funny. I think this is one of the only games that I've seen that draws this screen with objects rather than with backgrounds. So that's kind of funny. So now we'll slowly go to the next screen, which should actually make sense now. Yes, now I have this automatic pause screen. Oh, this is great. So now we're actually drawing objects. So this was a lot easier than I thought. I thought this would be more annoying than it was, which is why I put it off for so long. We should be able to toggle this on and off thing, which I can do, although it moves very slowly. Man, that was way too easy. I'm going to just comment out this debug printing. That was way too easy. Of course, we're still not doing the parallax. So now we should get this warning here. I'm actually just going to implement that because I think subtract X for the left display and add it for the right display. So I think this will be pretty easy. We add the offset here. And I'll actually add it before the offset just because I want to. And we'll just add it here. So this will be parallax as U32. Which should be correct here. In fact, we don't actually need this cast here, because that will be interpreted correctly. In fact, this actually we do need the cast there again to make sure that this gets signed before it gets sign extended to U32. That should be correct. Again, it wouldn't have mattered in the case of these little screens, just because none of the characters were like off to the top left of the screen. But this should fix that, any potential bugs that may have arisen for that. So we're good. Things are running fast. Oh, yeah. Nice. So let's see. Now I'm just like watching for anything else that might be sprites that I hadn't seen before because it's been, yeah, I just never implemented that. Yep. So that's new. We have this 1995 Nintendo thing down here that never showed up before. That's pretty cool. Looks like we had the right priority under his plane there. Oh, this is awesome. So now you can see we actually have Wario over here. Looks like we can clear the data too. So there's probably some save RAM stuff going on. Gonna need to persist that soon. So this is an interesting bug too. Every time this cutscene plays, it gets dark. And I don't know why it does that. But it seems weird because like something has been written to these palette registers. And I know that because like the background and the objects use different palette registers. Or it must be the LED brightness. Never mind, because that would cover everything. I wonder if I'm just masking those wrong or something. If there's some overflow thing that I'm messing up. I'll have to look into that. But I can skip this cutscene. And I can't let this play for too long because it'll crash. And now it looks like I can actually play Wario. Oh, that's down. There's my jump. Sick. Oh, I guess I can ram stuff. And I can get hurt. Look at me little. Then I can fall. Hey, this is cool. This is actually playable now. So that is rad. I'm just going to check another game really quick, which is Bound High, because I have been really looking forward to playing that one, actually, now that I have sprites. So this was good progress. I can always skip that little cat, but I like it. So there should be a couple differences here. I don't think there'll be any differences in this menu, but there will be differences in this cutscene. There's a bunch of stuff that was missing. I can kind of point it out to you guys. And I only know what it is just because, again, I used to be drawing the objects as just other backgrounds, and now those should actually work correctly. So there should be some explosions back here that should now show up. Yep, that's perfect. And I don't know if there's any other differences here for this part, because I'm not familiar enough with it. As you can see, there's also, it looks like there's clipping bugs on these clouds. That's, again, those are supposed to be scaled. Oh, see, look, here's some particles that are coming off of him now that are there. Nice. Oh, this gets me really pumped. So this is relatively straightforward, which has been pretty nice. I wonder if there's any more here. All right, so now you can see that this character here has eyes, and these little things looks like they have eyes as well. Although it looks like they're not using the parallax correctly. See that? Like the eyes always ended up on the right side. That seems a bit wrong to me because you'd think that those would be like aligned with the character. The eyes on the main character here work fine. We get that little score thing that comes up, and then it crashed. Of course, it went out of bounds, and there was a floating point up. But I'm wondering if the parallax thing here didn't work. Be Corey on good old Atwood's law. I actually don't know. Don't remember Atwood's law. We do shift to left 2, make it an I-16, and then we shift that right 2. So that should be okay. Unless the shift right isn't sign propagating. Oh, any software that can be written in JavaScript will eventually be written in JavaScript. Yeah, that's awesome. So true. Yeah, Cry said I should try to compile your emulator JavaScript. Yeah, feel free, man. That's what open source is about. What was I gonna do? Oh, of course. I know why. Because I'm adding the parallax here always, whereas I'm not doing the I should subtract it from the left and add it to the right. So that's the issue. So we'll do this. reorder these a bit here because the order here shouldn't matter. Addition is commutative. So do this, and then we'll say match I. Oops. So should be a sub here. And this will be right. And that should fix the little eyes on those characters. And then we can look into this code cleanup, but I think I might actually wait because it's pretty annoying to fix that kind of stuff on the stream when I have limited visibility. And the refactoring is just going to be so straightforward. Might rather do something interesting, but it's also 11:30, so I might as well just stop soon. We'll see. Happy to have done something productive at least, rather than just talking about the code, which is, I guess, nice as well. More than happy to share these projects. I'll paste the repo again, by the way. Thanks for the new stars, by the way. Crisis looks like it's just a matter of throwing out mini FB and replacing it with canvas. I hope it is. Unfortunately, one of the things I want to do with the bootstrapping is get window out of the emulator struct, or like out of the emulator module, and just like have all of that be piped at a higher level. The reason I didn't do that is because of the different updates. Okay, so now look at the particles, by the way, how they're different. This looks way more correct. But yeah, the reason I didn't do that was because of the bootstrapping stuff with the the emulator itself knows when to like update the window because it has like the main loop, so it kind of have to factor that out. And I just haven't spent enough time trying to figure out a better way to organize all that code. Might just be as simple as just making a run frame thing on the emulator object that will do, yeah, the inner stuff in that loop and then have the window do everything else. That's probably all it'll take, actually. And when that's the case, then it's even easier to do different bootstrapping, because that's kind of the idea that I want for the architecture here, is that the main file is just doing bootstrapping, and then emulator should be completely agnostic of what's actually routing what to what. The other reason, though, that I didn't do that, I think, now that I think about it, was because of audio. When we do audio, we're not just going to be wanting to run one frame. We need to run however long the audio buffer needs. So I figured the bootstrapping would be different, and I don't know what that would actually entail, so I just have not left it, or I've just left it for now. Anyway, all you should need to care about is that small bit of code in the emulator. And I'm guessing for a project like that, you don't really care about doing it so nice, so details don't really matter. Is that Legercha 64? Are you able to view it actually in 3D? Do you have some glasses that are compatible? I actually don't. But I know that this is correct because I was testing it with the side-by-side view. So instead of doing the red-blue, I just hacked together some side-by-side and did that like letting your eyes go out of focus thing. It's really it's really annoying and totally gives you eye strain if you do it for a long time. So I don't like to do it. But I did that to actually make sure the perspective was correct. But that was all the testing I did. And again, because the 3D on the system is actually so straightforward, like it's just drawing to two different buffers, and then with these like parallax values, it's pretty obvious whether or not it's correct. So I don't, I'm not terribly worried about it, at least in the case of these sprites. Although I probably will test it again at some point, just because I should. So another one of these games that will probably work really well now is Mario Clash. I think this had some cutscenes in the beginning that didn't show some pieces. Also, a ton of these games would have like that automatic pause toggle at the beginning, and a lot of the indicators for which one you're actually selecting wouldn't show. So I expect that to be showing up in a lot of these. Like this smoke that was here didn't show. This propeller didn't show before, I think. So that's pretty cool. This was a nice, straightforward change. I really expected the objects to be more annoying than this, so I didn't look into them, just because like the background segment stuff is actually a little more annoying with how you have to read the pixels, because there's a lot of like indirection per pixel. So also this never showed up, and there's this little flag that gets raised here that I've seen in like playthrough videos. Also, it seems like the positioning there was a little off, but maybe I'm just misinterpreting this. A lot more clouds here now. Also, the fact that the castle isn't continuous here, that's wrong. That's me not doing the background wrapping correctly, I think. Oh, we crashed again. But I actually want to watch that again just because the position of that ship seemed a little weird. The parallax on that. Just using like where they overlap as a center point and then the left and right here. Because the other thing too is you'll notice that like the parallax on the sprites matches the parallax on the backgrounds, and since I've tested the backgrounds and that looks like they match, then I'm gonna believe that that's pretty correct, or at least we have some here. Might actually be backwards for what's left and what's right, which would suck, but I doubt that's the case. Because it seemed like this was not aligned. Maybe it just is aligned with the left side of that castle. If the flag comes up there, right underneath where this is, then that's probably just how it is. No, so that actually was off to the left here. I wonder if that's significant. It probably isn't, and the only reason I say that is because in Bound High, the eyes on the ball thing were actually centered correctly. Let me look up a little playthrough video of this. Just to see. Okay, so here also it's off to the right, that's a good sign. Crisis, oh, you use threads. Yeah, I use threads. The only thread it's doing is the stdin stuff happens on a separate thread, and that's so that we can keep running the main loop without blocking. All that's doing though is it's reading strings from stdin and just setting them to the main thread. So given the fact that in JavaScript you probably don't need the debugger, probably don't have to care about that, because that's the only thing it's for. I'm going to pull this up one more time. Just so I can get past this cutscene where I know it crashes. I want to see how far it gets in the game, because this I remember also getting pretty far. But now I think it has some enemies here. Oh, this is proper now, guys. So he can swing around. Can he drop? All right, I'm in it now. How do I jump? There's jump. Oh. Nice. Oh, this is great. This is fantastic. Oh, missed. Oh, forgot how to jump. That's that button, yeah. The keyboard map that I have on this is super annoying because like the keyboard on the actual system has like 2 D-pads and stuff. Doesn't sound like that in itself would be annoying, but then the problem is that like when you map it to a keyboard, it just ends up being super unergonomic. Like I have WASD and IJKL, but then like if my fingers are doing that, where do I have like A and B? I thought about doing it with my thumbs, with like C and N. I just ended up doing it with like F and H, and it's not good. But that's the kind of thing that you make configurable for that reason. Let's see some other things. Some other games here. Again, I haven't like seen any of these running in the emulator with Sprite, so I'm just going to be running a bunch of these now. Just seeing what these look like. This is pretty cool. So I mean, this is a really fun bit of this emulator development. Like when you get significantly far, that you're making a lot of changes that suddenly enable a lot of stuff. At the beginning, you're kind of just trudging through details, which is also fun in its own way, but it's a different kind of thing, you know. TJ says L shift and R shift. I guess you could do it with the pinkies. Is that what you're thinking? I guess that can make sense. That's not a bad idea, actually. But then you also have L and R buttons. But maybe could do the like V and N for A and B, and then left shift, right shift for L and R. And then for start and select, could do like G and H. Oh, that's dumb. You're on your own, sir, he says. Yeah, there's buttons. What I really should do is get like a what are they called? There's one of those Atmo micros, I think, that it's really easy to configure as a human interface device. And I could just bit bang the actual controller and just make it a USB device. That'd probably be best for this. Bicorian says easiest to just map it to an Xbox controller. Even then, you have one joystick for one of the D-pads and the D-pad for the other one, which generally wouldn't be much of a problem, but in games like Tolero Boxer, it would be really annoying. Because, yeah. Now I'm getting distracted because I'm actually playing this game. I don't actually know how to do this. Let's do that. So I guess this is some turn-based space war thing. Weird. It's also weird that those grid lines just disappeared. I wonder what that's about. TJ says Steam controller. Does the Steam controller have two D-pads? Oh, it does. Nice. Yeah, that'd make a lot of sense. Bicorian says Xbox controllers are more common. Yeah, and I mean, at least I have one, but yeah. I'm not too worried about doing those kind of config, just because, yeah. That's the kind of, like, packaging stuff I just don't want to deal with right now. But I might buy one of those just for this. So in this game, I think, might actually be playable now. In terms of, like, game playability, we're actually getting pretty close to supporting a lot of stuff. So all I know about this game is that there's like these monster things. I don't know how to fight them. I guess I like punch or something. I don't know what to do there. But hey, they show up now. I think there's another one over here because I went down this hallway earlier and just died, and I have no idea how to fight those things. Games are weird. Trying to remember other games in here that just don't just crash. I think Virtual Lab is playable, but just looks like the worst game. Like, so it looks like these menus are super misaligned. No, they just look like shit. TJ says Steam controllers on sale until January 2nd. Nice. So the goal was to develop a super cool game for a new VR console for Nintendo. And this is what someone came up with. So whenever you feel like maybe your skills as a developer are not up to par, or if you're just having a bad day, just think of this game. Crysis looks like no one ever tested mini FB on Linux. I believe there might have been certain Linux configs that it was tested for, and then other ones maybe not. Would be interesting to get some extra eyes on that. Emoon, if you open up an issue on the repo, he's really good at getting, like, following up with that stuff. And he also doesn't work on Fridays, so maybe I shouldn't say that, but he works on personal projects, so he's probably quite available then. In fact, I'm a bit surprised he's not tuned in right now. He might be. Tolero Boxer will probably show more stuff, but it doesn't actually go into the game because it's one of those ones where I haven't implemented the floating point stuff, so it just kind of crashes when it gets sufficiently far. But what I like about it is it's got this little boxer guy. This is actually one of the better games for the system because it's one of the games that's actually from a first person, which really helps. I mean, considering they were trying to make a VR console work. It's first person, it's a boxing game, so you can actually get out, like, a lot out of the perspective. Fortunately, I can't show you because it doesn't work in the simulator, but it is actually pretty cool. So a lot of these ROMs just don't get very far. I wonder if virtual bowling looks pretty cool now. So this runs really slow in parts of the cutscenes. Show you a little bit of the console window. The reason why is because, like, it'll change the display stuff and then the screen will go black, and then it'll just rely on timer interrupts to update some of the VSU registers, it looks like. And those timers just happen like a ton. I guess it's just in some loop where the timer just triggers over and over again. And it just really slows down because I'm printing whenever it enters and exits a interrupt or an exception, I guess is what it is by that point. And I'm doing that because it's really useful to see in other contexts, but in this game, it really sucks. I was thinking about doing, like, some conditional compilation stuff to, like, have a build where it does all this debug printing and then one where it doesn't. The only reason I was thinking of conditional compilation for that is because I don't even want it to evaluate the strings that it would normally print when that's not desired. I could just use a print routine that uses a lambda or a closer and we'll do that stuff, but yeah. Anyway, that game still looks like crap. I kind of want to try to play this game again. Also, the password screen on this should actually work now. It didn't before. Nope, that's still crap. I wonder if that's scaling stuff. I wonder why that is. Can I not just hit A lot or start a lot? Do select. Okay, that works. Oh, I have a gun. Apparently R is a gun. I shoot him a lot. Hey, I'm trying to shoot you. Oh, I aim with... Oh, man. Awful game. But hey, I, like, lived or something. Cool. This game is actually playable now. It sucks, but it it's really not fun to play in this, but it's actually playable. Okay, I got an orb. How fun is this, though? Playing a game, my own emulator. I think I need to get to a door. Oh, I got it. Nice. I beat the first level. Unfortunately, I can't enter passwords because that screen's just totally broken. It's Corian says that's pretty cool. It's like an early Doom clone. Yeah, kind of, but it sucks. It's awful controls. I mean, it's awful controls playing on a keyboard. Also, I like the time limit, actually. That seems like it would be a really annoying thing. It's actually pretty cool. Oh, hey. I need to shoot you. Where's my shoot button again? Oh, lost it. Dead. This was cool. Not terribly much code. Again, like especially this like right pixel stuff could be done, but I just want to commit this for now. Nice. And then I'm gonna merge this to master. Sometimes I do this stuff on a branch, but I really don't need to. When it's just me working on the project, just a habit. And I always forget how to delete a branch from the remote from the local machine. I always forget the command to do that, so I just go in here and do it. Should probably update like the screenshot and stuff too. Might as well do that now while I'm just sitting here. Let's get a good one. That's also the other thing that's really nice about having the debugger, is I can freeze frame, which is pretty cool. Looks like Cry's got the emulator to run somehow, which is pretty cool. I don't think it's not really doing anything weird that like relies on endiness or some, yeah, sketchy code. For the most part, at least not in the actual emulation. Although, I might end up doing some of that by the time I get to the floating point stuff, just to reinterpret the register values as floats. Basically, any game that I'm going to pick to use for screenshots is going to have some kind of bug. So I'm just going to pick a couple. Also, I really like the screenshot that was there. That's there already. And the reason why this is there, it's this like 30 minutes have passed, you should take a break kind of screen. This is actually the wrong text. Like this was really early when it was actually before I implemented screen scrolling. And this was, I guess, text that was displayed on one of the windows that's normally scrolled off the screen. I guess I scroll it back on when some timer goes off and you're supposed to take a break or something. I've never let the emulator sit running for 30 minutes, so I actually don't know if they'll show up. But anyway, it displayed the wrong text, and the text was that I should take a break, so I thought that was really funny. So I really liked that as a, initial thing. Anyway, I think this is one of the screenshots I'll take. I think that's kind of cool. I'm just lazy, I'll just do it with snip. I can crop it in Photoshop in a sec. I should just do that now. Whoa. Big Photoshop. Oh, so satisfying to see this stuff starting to run more and more. That is what I like about this stuff. Cool. So that'll be one of the screenshots. I'll take another one. We can do one of the ones from Bound High, because that game's rad. Especially the little cutscene it has, I really like. Bikorion, you know you've been programming too long when the emulator you're programming tells you to take a break. Yeah, that's exactly what I liked about it. It was super charming. Especially that it was the wrong text, but with the wrong text with the right message. I really liked that. Let's get into this cutscene, because it has some cool stuff. There's a part where the character like looks up at the camera. I really like that. These are really charming little games. There, I want that one. That's why it's kind of a bummer that they were on Virtual Boy. But it's been a fun project. Oh, whoops. Got the title bar. Is that correct? Yeah. Nice. We'll do Mario Clash. The floating point stuff, I think, is going to be the next on my list. The affine stuff as well, I know I could do, and that would at least improve the compatibility with the games that already work. So I guess that could also be a good one to do next, but I'd kind of rather do the floating point stuff just because it'll make so many more games start to work more. And I want to do both, like, in the next couple days. So probably next week when I stream again as well, I'll probably go over some of this stuff. Go over the progress I made. Then we'll move on to Restendo, which will be fun to pick up again. I probably won't do any coding on it before then, though. Or maybe I will. I don't know. I gotta change that README and stuff as well. I'll do all that next week. We'll do some admin stuff. Reacquaint ourselves with the code. Is it just me, or did that ship just not show up again? Hold on. TJ, so you're going to be pretty strict about streaming once a week? Yeah, I think that's what I'm going to start doing. Dorero says, are you still traveling a lot for work? Nope. I am settled down. Guys, I think I did something funny. I don't think I merged that other branch that I totally deleted. So I need to do some Git stuff. Whoops. That's what I wanted. And now the Mario Clash stuff should look correct. This shouldn't have been, these two screenshots shouldn't have been any different, I think. But yeah, not traveling nearly as much for work. Might still do a little bit, but mostly in the same place now. So getting on a more regular streaming schedule, I think, will be good. Looking forward to working on that project a bit on my off time as well. I think we'll be able to make a lot more progress. Like, N64 is more complicated than this system, but at the same time, it was like I could work on this whenever I felt like, and in like 2.5 weeks, we have something that's playable. Kind of says something about the format. So I'd rather find something a little more balanced. I didn't mean to like... I don't really feel apologetic about it, but like, I never meant to like kill the Rostendo project. Just didn't make sense for me to work on it for a while. But it's cool that all you guys still are interested in that stuff and still tune in. Really appreciate that. Haven't streamed in 6 months and I turned it on. And there's a bunch of viewers still. That's pretty nice. Nice to see the friendly names. Not necessarily the friendly faces. Maybe I should take something from Wario instead. Make a bit of a better screenshot. Oh, so nice to see a bunch of this working now. It's really cool. Why does that get darker, though? So weird. That's jump. Up, up. That's so cool this is playable. Looks like the little timer down there is working correctly too. That's nice. Let's do that as a screenshot. Wait. I didn't like that Wario was blinking. Oh. That'll do. But yeah, especially coming into the new year. I want to start streaming again because I had a lot of fun doing that. And I really like sharing the projects that I'm basically working on anyway. Yeah, this is nice. All right, so what we'll do, put this in the get some PNGs. I'll overwrite the current screenshot with this one, and we'll call these screenshot 2 and 3. Sometimes it's nice to do these little packaging things. Just chill. Don't really mind you guys seeing the other things I've been playing with. Ah, Christ, I forgot you can't just sleep in JavaScript. But can't you do like a set timeout and then run the next frame in that? Because then you wouldn't have to sleep. You would just kind of invert your main loop. That would just always run that on an interval. Which might have some drift, but that should work. Timeout will make sure, well, I guess interval as well also does that, but no. Think of the case where it actually takes too long, but no. It's more just funny that you're doing that. Yeah. I just realized this says Rostendo 64 in it. Awesome. That's great. Let's call these screenies. Don't care about the name. TJ also says request animation frame. That would work. Nice. See how that looked. Bam. I should really have a forced screenshot, shouldn't I? Also, I was thinking about name changes. I might call it Rustule Boy. Something else stupid like that. If you guys have any suggestions, I'm all ears. Nice. Virtual Rust. Could be a good one. Rustule Boy sounds better. Just go around. I think Rustule Boy sounds funnier, which is an appealing quality. There we go. Looking good. It's fine, but Virtual Rust can be shortened to VR. Actually, a bit of a bummer we didn't get any more of the backgrounds in this, because that's kind of what makes that game shine, but that's all right. Not too concerned about it. Nice. Crisis, it compiles the JS already. That's awesome. By the way, guys, I noticed a bunch of you have that like Twitch Prime badge. What does that mean? What's Twitch Prime? Oh, that was the other thing I'm thinking about doing. Thinking about starting a Patreon. They would. Well, I don't really have anything concrete that would go into, except maybe buying hardware. That's definitely cool. Crisis, Twitch Prime is Amazon Prime. I guess that's better than Twitch Amazon. Twitch Turbo as well. Sounds pretty prime. Sounds Turbo Prime. All these just sound like Transformers. So basically, if you have Amazon Prime, you get Twitch Turbo. Hey, I should have that then. Probably have to connect it, I guess. Plus a free sub per month and free games. Oh, that actually sounds nice. Cool. Well, I think that's about all I really wanted to get through. It's just some kind of progress and talking about what I want to do with the stream moving forward. It's basically just start up every week. Beyond that, I don't really want to make any other changes for now, just to feel that out. So that should be cool. Yeah. So I'll probably head out now, because it's been 4 hours. Keep doing that. Anyway, thanks for watching, guys. And I'll see you next week.